not yet. There we go. Super. All right, so now we are continuing with the program here on the Keynote stage. We have a bunch of super awesome topics that'll be discussed here today. You'll see them up there as well. And hopefully you'll learn something new and get to hear awesome stories. I counted that there are at least 11 different topics that will be discussed here on the stage. We have a few Aalto showcases, previous Aalto students, people who have worked at Aalto sharing their learnings or might even work still at Aalto. And then just a bunch of really cool different topics from different subjects. And we'll just start the program here right away. The first speaker comes from Holvi. Holvi, which was founded in 2011, describes its offering as banking for makers and doers. So banking for SMBs, small and medium-sized businesses. In fact, actually, I've been using Holvi, and it's a really great product. And they got actually acquired a year ago or so by a rather big bank. I think one of the bigger banks in the world, BBVA, and they're still focusing hard on creating and making the product even better. And today we'll be hearing on how to build a banking service. We all know that it's a heavily regulated industry. It's super tough to get things to work. And that's why I would like to welcome up onto the stage Sakari Ellonen, who is a senior financial infrastructure engineer at Holvi. Let's give Sakari a warm welcome.
Is this better? I feel a little bit limited by having to hold it all the time. But yeah, and after walking through the bug, I will talk a little bit about legal stuff, criminals and the threats that we face. But first things first, what is money and what money is not? So money is not only gold coins and bitcoins. Rather, the definition of money is super vague. Money is whatever people accept as payments for a good or service. And banks, they keep record of debt. I think I was in high school when I first heard the idea that when I have 100 euros on my bank account, it actually means that the bank owes me 100 euros and that my money is maybe somewhere else. I assume that you have also heard this about banks, but let's still think about it a little bit more, because this simple statement, it has some fundamental consequences which are not so obvious. And let's take it to the bar. Our example persons, Alice and Bob, they have money on their bank accounts. Alice has 100 euros, Bob has 300. Now, Alice is sitting at Bob's bar, and she orders a drink. This order creates a debt position of 6 euros. And before Alice pays her bill, she owes 6 euros to Bob, just like Bob's bank owes money to Bob. After she has paid the bill, Alice has less money on her bank account and Bob has more. And that's simple enough. But let's return to the second part. Because you see that there is that 6 euros which appears seemingly out of nowhere. No, this is fine. No, it's all right. So the 6 euros appears seemingly out of nowhere, and it looks a little bit weird. Is like Alice has not lost anything, yet Bob somehow has more of something. And does it mean that the money owed by banks is somehow different than the money owed by people? I wish it were so, because I recently bought an apartment, and the money that I owe it's not monopoly money. It's very much the same. So, but can it then mean that here the total amount of money in the world has increased by 6 euros? And yes, it does. The promise of money is money. So let me state that again. The promise of money is money, which is quite a mindfuck. But whenever there is a lag in payment, whether it's hours, days, or years, there is an expansion of money. Well, other properties are that money and promises of money can be sold and bought. You buy money when you go to Forex before your holidays, and you buy a foreign currency. And similarly, promises of money can be bought. Like, if we peek a little bit to the future, and Alice has ordered for her friends 50 beers, and they're still going strong. Now, Bob has 300 euros more. And she can go to Eve and say that, hey, Eve, I got these girls at my bar. They're drinking and they're going to pay me 300 when they leave. And Eve's going to be like, oh man, I can't miss this investment opportunity. Bob tells her that she can have all the 300 if she gives Bob 250 immediately. And it's a deal. Now, Eve's got those. I'm sorry about this. So now Eve's got those 300 euros, and it's as real as any money on Wall Street. And I want to emphasize that this is not a metaphor which only worked in some ancient society before real money systems were developed. Rather, every time I order a beer and I don't pay it immediately, the amount of money in the world increases. The fact that money is at the same time very limited, valuable and precious, but also created and destroyed all the time, makes it very complex for philosophers and economists. Some of the oldest money theories go back all the way to Copernicus, the guy who figured that Earth is revolving around the sun. He was investigating how all the new gold from the Americas was affecting currencies in Europe. But the same fact that money is just a contract between two parties, whether it's between me and a central bank or whether it's between Alice and Bob, it means that it's very simple for engineers. It's just a number that you write in the database. And there is no money technology beyond that. So the bank keep record of debt, and keeping track of the debt is actually the origin of relational database systems. That's just for curiosity. So here's my building a bank 101. The step 1 is to have a database where you keep track of the money that your customers have earned and spent. And the step 0 before that is that you yourself have treasury accounts in your own systems, in other banks, in the central bank. And there is no secret in sending money either. You just need to communicate payments, which are changes in debt positions. And what we send between banks is quite straightforward XML. The channels to deliver the XML are a little bit mysterious sometimes, but it's only about security and reliability, and to tell the truth, also legacy. I think if the European Payments Council told us tomorrow that from now on we are going to deliver the payment files via WhatsApp, I wouldn't have to change the whole of systems too much. In fact, I would be really happy to sometimes send an angry emoji back when we receive bad data from other banks. And to prove my point, here's an example of an XML file containing a payment. It's a SEPA credit transfer. At the top, you have payment IDs, which are meant for bank to bank. You have the amount and date. It's 12 euros 34 cents. It's from whom. Basically, that's just an IBAN. And then to whom. There's another IBAN and name. And then there are payment references, which are shown for the person who receives the money, that they know, for example, which invoice was paid. However, simple does not imply easy. Let's look at the life as a payments engineer. The challenges are very much the same as in any distributed systems. The ACID database concepts like atomicity, consistency, isolation, and durability they come in very handy, and as comes logging essentially everything. Of course, there's a high emphasis on correctness, because fixing data afterwards may not be possible. If you sent out that money, then you have sent it out and you might never get it back. And obviously, security is super important for us. So I promised a bug. Here is one that almost happened in Holvi systems. Luckily, it never actually materialized. But it's very easy to make, and it's exemplary of any distributed system. On the left, you see a Holvi ledger, which is basically just bookkeeping and accounting, how much money Alice has, how much money Bob has. Then there is a banking gateway, which is another server inside Holvi, where payments arrive from other banks. And the payments arrive in payment files. They are grouped in batches, and they may not have unique IDs. And that's why we have to give them unique IDs somehow. In this example, let's assume they are given randomly. So there's this first payment gets ABC, the second one DEF. Now, a naive implementation of how to read those payment files is that your code goes through the file, one payment at a time. It reads the payment, saves it at the gateway, sends it forward to the ledger, then proceeds to the next payment, blah, blah, blah. And now, this all happens inside a single database transaction, which saves all or nothing. So if later in the file, the code crashes at the gateway, it's going to roll back all the data at the gateway. But you have already sent this stuff into the ledger. So if you fix the bug and you rerun it such that you go through the payment file again, then there are going to be new files. There's going to be new payments at the ledger. It cannot tell them apart. They got new unique random IDs. Payments are duplicated. Your customers suddenly have more money on their accounts than they should have. And, well, they can cash in, and believe me, they will. The main lessons from here are that distributed systems are hard no matter the industry. So study database asset concepts carefully. They're not a silver bullet. Rather, database rollbacks are a weapon to be wielded carefully. And code must run in small re-executable steps. Sounds, again, very self-evident, but it often takes more time to design it like that, so it's easy to forget. I might also add that randomness is maybe not as cool as it is often in mathematics. In the previous example, if the unique IDs were not random, it would not have been a bug at all. There would have been no problem. And lastly, working at Holvi is challenging and fun. So, as all good engineers, you measure twice, cut once. But enough technology. Banking is not only about money. We have legal and social responsibilities. Leaking someone's financial data can be life-changing for the worse. And if it happens to us, there will certainly be investigations into our systems and practices. And if we are found guilty of negligence, there will be consequences. We lose our license to operate, or in the worst case, somebody might even go to jail. And then there is money laundering. I think that when I started at Holvi, I was imagining that we would be under constant attack from cyber criminals, that they're like orcs pounding against our gates, and we are leaning against them on the other side, wielding our cyber swords unsheathed. But quite more often, the victim has been somebody else, and the money is just tried to channel through us. And that's money laundering, and we have to notice it. This security starts at KYC, which stands for knowing your customer. So when somebody signs up at Holvi to sell espresso machines, we have to know that they are who they claim to be, that the company exists, and that the person who signed up is actually allowed to represent that company. This is relatively easy in the Nordic countries, where online verification systems are common and good quality. Like in Finland, we have these banking credentials, where you can, if you log in with your banking credentials to Holvi, we can be pretty sure that it really is you. But elsewhere in the world, it's much more difficult. Many services rely on selfies, where you take a photo of yourself and you hold your passport next to your face in the photo. Those are relatively easy to Photoshop, and it's hard to tell a fake one from a real one. So nowadays we have these video interviews, because modern passports, they have these optical security features which are visible against the light when you turn it around on the video. And it has really brought down the identity theft problem at Holvi. And so why is this important? Well, we got fraudsters. When an innocent person buys an espresso machine at Holvi online store, and then if the seller never delivers the product, of course we initiate the legal process at that point, but if the identity of the seller was fake, then what can we do? You can be sure that the money is already not on our accounts anymore, and we have to compensate the victim. And it's also very bad PR. Money laundering is slightly different. So, what if the seller and the buyer is the same person, or if they collaborate, then nobody will come and tell us that there is no espresso machine. Or if there's a campaign to organize help in a conflict zone, and there's a lot of money, but all the money in fact goes to a terrorist organization. So Holvi has a legal responsibility to detect these criminals. Very much different than, for example, Shopify. We are an independently regulated system. We are not built on top of another bank. Holvi is built from the ground up, and we are responsible for this stuff. And while it may sound a little boring and bureaucratic, that all the paperwork, but it's also, it brings certain seriousness to our work at Holvi, and I definitely like it. You know, code that catches the bad guys, it's superhero code. So, if you can remember only one thing from this presentation, try to remember that even though money is very complex and often hard, and its definition is hard to fully grasp, it is also extremely simple. And if you can remember two things, try to remember the last stuff, that working in a regulated industry it may sound just boring, but it's also very rewarding. We are 58 people working at Holvi. We got 19 different nationalities. We work in the Lapinlahti hospital, so it's offices with a sea view. Come talk to us. I think I was pretty exact 0 now.
Awesome. One quick question. You've been here, did you come already yesterday to the event venue?
No, unfortunately not. I'm in the process of moving apartments this week, and I've got a small baby, so there's a lot of things to do. So I just came in here and to talk, and then I'll stay a little bit at our stand now after the talk.
And what would be the coolest thing within the finance tech sector that somebody could build during the weekend, in your opinion?
I think the most interesting part lies in that detecting those bad guys. There's a lot of opportunity there, and the problem domain is extremely difficult because they are super smart and they get smarter all the time. Money is moving faster and faster. It's only like last week the European instant payments were officially launched. So the movement of money is going to become more rapid all the time, and it's going to be a gold mine for a lot of criminals. And like working on the side of good guys it's a big thing.
Awesome. Let's give Sakari one more round of applause. And probably to catch those guys, we need technology to enable that. And AI is probably one of those things that needs to be somehow implemented into the process to catch those bad guys doing not so cool things. We all know that AI is probably currently one of the hottest topics there is. Everybody's talking about AI and machine learning and how that'll change everything, and suddenly we won't have any jobs in 10 years. And that's why it's super interesting to have one of the leading AI laboratories share their story. This young company has already over 20 employees and has clients within the finance sector, within the transportation sector, and within the media sector, and their founding team includes backgrounds from Nokia, PVC, Electrobit, and Valossa. Next up, I would like to invite up onto the stage the co-founder and chief commercial officer, Ville Hulko from Silo AI.
Check, check. Hi, I'm Ville, the CCO of Silo AI, and we build artificial intelligence as a service. Today, I was scrambling my head on what on earth should I talk to you guys about, because I'll give you a heads up right now, I'm not the most technical of founders. Instead, I chose a topic that I think in a hackathon environment like this would maybe touch upon all of you. How to found a startup. And as we're discussing about AI, of course, the hot topic of the day, let's add in a little bit of a flair. But before we get kicked off, I'd like to kick off with a story about a particular founding story of a startup, which was one of myself. And the story kicks off in Oulu multiple years ago when I started off my work for the first time as a research assistant at the Fable University of Oulu, Department of Computer Vision. Now back in the day, I joined a group called Personal Content Channel. That was a time prior, a time when the men were made of iron and the woods were made of steel, or how was it? And we weren't using buzzwords like AI at the time. We were talking about NLP, computer vision, signal processing, and all this good shebang. So I joined a research group with a group of brilliant people. We're combining computer vision, image recognition, facial expression detection, heart rate detection, to dialogue understanding from NLP, as well as to audio processing to recognize particular sounds like gunshots and laughter. So basically, what we ended up doing is then sort of toying around, hearing the first concepts of, AI being this kind of a cool thing. So we go there and we enter a pitching competition called the Midnight Pitch Fest, right? One of the largest ones in the northern Finland. So we get to the stage, we're a group of engineers and, do this. And prior to starting off, we really wanted to tweak it along, so we took in also another founder, Mr. Harri Pesala, the CEO of Kubikasa, and together we tweaked the pitch. And we took that and we created what we called the AI-powered video search. And we went to the stage. And we delivered the pitch where we predicted that content discovery is going to be one of the biggest problems in video so far, that voice control is going to dominate the whole world and so forth, and we ended up winning. That was a big moment for us, and that was the day when we decided that it's truly time to turn the research group into an actual company, led by Dr. Mika Rautiainen. Another thing that we found during that day was a consultant who helped us to take ourselves to Silicon Valley. Because we did know at the time, many years ago, that there is no market for AI at this stage, because we're a little bit early. So that is exactly what we did. We took ourselves, we boarded a plane, we flew over to San Francisco and drove to Palo Alto. And one of the first meetings that this incredibly expensive consultant booked for us was a meeting with Google. And with YouTube, one of the heads of YouTube. And we entered the office, it's a beautiful one with a red play button on the front. And we go there and we sit in the meeting and the guy has heard a million pitches before, and we come in and we deliver a pitch about how AI, curated content control, voice control, and all of these things are going to change the world. We show him a demo, a voice-controlled, natural language-driven movie search demo where you could make queries like, find me a movie where a boy learns he's a wizard, and it mystically looks inside the movie and brings it up. Went perfectly. And the guy is sitting there silently all the time. I swear to God, he's sitting in this position the whole time. And when we finish, he just keeps sitting like this. And he asks us one question that I will never forget in my life. So what do you guys want? Do you want to sell the company? Do you want to sell a license? Do you want us to subscribe to your service? Why is it that you're here? What do you want? And I swear to God, you could have heard a feather drop. Not any of the doctors and PhDs of computer vision, not the fabled old school CEO of Kubikasa and myself, the fabled hustler, had no idea this kind of a question was coming. And that is the question that I want to ask you guys today. What do you want? Why are you here at Junction today? 1,500 of you making cool shit for cool people, for cool cases. But why is it that we're actually here? And my hypothesis is that there's two main options. The first one is indeed to build cool shit, right? How many of you are here to build cool shit? Let's get a show of hands. About 50%. Okay, cool. And if that's what you're here to do, you're doing exactly the right thing. You're grouping up with people, you're finding real-life use cases, and you're deploying. The second thing, my hypothesis is that the rest of you are here to do in the long run is to found a startup, right? To leave behind the old dusted corporate world and become the fabled entrepreneur, Mr. Elon Musk or Mrs. Elon Musk or whatever. And if you're looking to do this, you've gone to the right place as well. Because this is the place to ask the questions, to go to the Finnair track, to go to Kone track, to talk to those people and ask them and pester them and get to know the problem and hopefully craft them an answer. And after that, what happens? You know, you guys want to go out and raise some money? No, you don't want to get employed. Because as most of you, because I'm talking from a corporate point of view right now, I'm a corp guy. And what we want to get from you is to employ all of you. Come to our organization and do cool shit with us, right? Stick to your ground. Instead of going into the organizations, provided that you're brilliant enough, do it as a consultancy work. You don't need to necessarily have a brilliant business pitch or concept right now, God alone, no funding. But instead of putting yourself in there, start off as a consultant. That's what Peter Sarlin, our head scientist, did with the Central Bank of Europe. And thus, many years later, Silo was born. But that's not what we're discussing today, is it? The question was, how do you found an AI startup? And to define AI, let's take a look at the very simple definition. What is AI? Absolutely nothing. What we refer to as AI is a combination of machine learning, computer vision, and natural language processing. And what the fools refer to as AI is bots like Siri and chatbots that have absolutely no learning inside of them. So next time someone says Siri is an AI, kick them. And to get moving with AI, we've reached now the point, and most of you hopefully are already deploying these tools in the hackathon today, is that we have access to an array of wonderful toolkits. You no longer need to be a PhD of machine learning or computer vision to become an AI company. But the catch-22 is, if you look at Slush 100 applications right now, I'm willing to bet 70% of all startup applications in Slush this year proclaim to be AI companies in one way or the other. Right? So the idea is you take your old business and then you take a little bit of AI with the butter and you smear it on top and then you become an AI company. These tools are not what AI is about. What AI is about fundamentally in business, in becoming an AI-first company, is one fundamentally very simple thing. The human. The human in the loop, the learning loop. And this is technically a very simple thing to say. But fundamentally, once you start thinking about your business concept, this should make yourself click just a little bit in the way you think. What does human in the loop mean? It means that every time you build a transaction, every time you build a service that is being used by a human, how do you construct it so that every one of those human tiny transactions makes the service a little bit better. Let me give you an example. You are the patron of a steel factory, right? You produce world's best stainless steel, and you have a beautiful visual modeling system that detects all flaws, made by Eyeball 1.0, right? When you detect a flaw, take a picture of it, convert that into learning material, and feed it back to the system. An example of a learning loop. Another example of a learning loop is if you are, for example, a human conducting very simple customer transactions every day in your life, how do you start quantifying those transactions? Do you keep track of which kind of queries do you get in? Or as an engineer, how do you build a system that keeps track of the queries that come in? Because as you start finding those, you can turn the whole thing around and make that into a learning system. And the point of that is never, and I repeat, ever, at least in 2017, to replace a human worker. That's not the right mindset to take. But the right mindset is, how do we construct the system so that with each transaction, the human becomes more efficient, augmented? What I asked you before is, what do you want? If you want to build cool shit, Silo AI is currently creating state-of-the-art machine learning solutions, computer vision solutions, natural language processing solutions for all kinds of companies, for central banks, investment banks, private banks, industrials, airlines. We're today sharing a booth with Finnair on the other side, and also startups. If you want to build cool shit and you're interested in machine learning, we have internship positions open, and we want to take you in and make you understand the fundamental framework of how to implement ML. If you want to found a startup, the difference between a technical company and a product-driven company is that the technical company has to crack the fundamental problems of building the engine first, and there's a lot of different steps that you have to take before you get to deploy. And that's what we help with. We have the client companies with real problems. We then help with UX, we help with deployment, with frameworks and everything like that. And it's up to your company to do what you do best, build the engines, and we'll help with the rest. So the question is, what do you want to do today? What do you want to do tomorrow? And if the answer is you want to build cool shit, or you want to found a startup, call us. Thank you so much. Oh, if there's any questions, I don't know if we have time, but I love to answer. And we have some more technical people here as well, so if you want to discuss about ML, swing by the Finnair booth.
We could do actually a quick Q&A session here while we get the second or next speaker up and running. Or can we do that? Yes? Let's do that. So just really quickly, you started the company back in last fall or something?
This spring, actually.
This spring, okay.
Yeah.
And then you have a lot of really talented, really experienced people behind the company.
Mm-hmm.
I mean, why did these people join the company? What's kind of the big picture on why they saw it as? I mean, they're leaping from huge organizations into a new startup where the future is completely uncertain. Why did these guys join?
That's actually a really good question. And the most straightforward answer that I can give is we're actually not a startup. We didn't make the decision not to raise any funding or jump through any of the hoops startups normally do. Instead, what we did when we were born is we took two fundamentally extremely well-renowned research groups, we mashed them together. They used to work with central banking before, and now the business guys like us and Tero, we started giving them other cases from other industries. But fundamentally, it's not a startup or it's not a corporation. It's a collection of academics, of researchers that create an equally academic or research-oriented, solving cool shit kind of a content environment in the company without the burden to teach, to apply for Tekes funding and through all of that stuff that you necessarily are not so keen on.
Right. And then one last question before we're ready for the next speaker. Is Finland a good place to build an AI company?
Absolutely.
Or if you could choose, would you rather go and start somewhere else?
No. I would stay in Finland because we're very modest people and we say that we don't do anything properly and our technology is bullshit and everything like that. But if you look at, for example, the University of Oulu, Dr. Matti Pietikäinen, Fei-Fei Lin, the discoverer of ImageNet, has about 38,000 references or citations. Matti has 48. Right? We have Teuvo Kohonen, we have state-of-the-art technology. So this is a really good place to start and to found. And the fact is, if you go to Silicon Valley today, you go there to burn money. You don't go to build core technology, you go to build applications, raise funding and burn money. So Finland is definitely one of the best launch space countries that you can start off with.
Cool. One super last question. Where do you see the company in 5 years?
Hopefully, the #1 artificial intelligence provider, at least in Europe and hopefully globally.
Awesome. Let's give Ville one more round of applause.
Thank you so much, guys.
Super. So while we're figuring out the last details for the next presentation, we're going to go, I believe, into slightly more technical things, even from the previous presentation. And we'll be hearing about predictive physics for predictive physics simulations in game merchandise innovations. Is that correct? No.
Game mechanics.
Game mechanism. Okay, there we go. Awesome. So I got my notes slightly incorrect here. That's okay. So this is going to be rather technical. Am I correct? Or no?
Not so much. It's kind of a new mindset.
Okay. So it's going to be a new way of thinking. And these next few speeches are going to be part of the Aalto showcase. So people who have some kind of a connection to the Aalto University here and what they have learned here and then how they have perhaps applied that in the awesome world of tech. But without further ado, let's give Perttu Hämäläinen a warm welcome to the stage.
Thank you. So I'm a professor of computer games at Aalto, and I'm presenting this piece of work that I earlier presented it at KaiPlay. That's an ACM conference focusing on human-computer interaction in games. And this is kind of my own hobby project, a 2-week retreat last summer. And then Mao Xiaoxiao, a student, worked on the core engine tech. And also then Jari Takatalo and Julian Tokelis helped with the writing. First, bit of personal intro. So what we do at Aalto's Game Research Group, and I'm also leading the game design and production major. So my own mission is to make people healthier by motivating them to move. This is my own PhD work back in 2005. Let's take a look how that plays. I don't know if we have sound, because we didn't have time to test. Well, we don't. It doesn't matter. So it was this kind of embodied fighting simulator. I've been working a lot on this kind of empowering of movement, exaggerating physics, and combining movement tracking and physics simulation in a way that empowers you, makes you feel like superhero. Okay, then this is our later success story. So it was earlier a research project started by a postdoc and myself, and then we got Tekes funding for taking it further and launched a company last year. Now the company is 1 year old. We've already sold or have over €1 million in sales. It's in 35 countries. This is without any investment. And yeah. Then we do AI like everybody else nowadays, but our focus here is on movement. This is, for example, our SIGGRAPH work this year. An AI climber, it only knows that, okay, there are holds, I have this kind of body, it has no animation data whatsoever, then it improvises the movements. And today's work is kind of an experiment or series of experiments of putting the player in the AI's role in control in the physics simulation, because these control problems are actually super difficult. there's so many degrees of freedom in the human body. In that climber model, for example, there's 30 degrees of freedom, and then you need to coordinate them, the joint rotations and so on, over time. So it's easily hundreds of variables that you need to optimize to even do a single move, and then there's a chain of movement. Anyway, so we've created a series of experiments where we kind of try doing this AI thing ourselves to kind of understand what's so hard about it and how would a human do it if we didn't have all this kind of embodied automated knowledge that we accumulate since we are born. How many of you have ever worked with a physics engine? Coded some game with physics and some. So basically nowadays you can just download a physics engine and instantiate objects and then simulate, and everything works. Things bounce and rotate and so on. But kind of in game applications, earliest ones were, for example, Incredible Machine in early 90s. Then you could say Angry Birds is kind of, it's a physics simulator, but with pretty graphics, hint of a story. And as computing power has grown and simulators have matured, games have progressed from rigid bodies to soft bodies and roped, like in Cut the Rope. And then from soft bodies to fluid simulation, like in Where's My Water, where you kind of draw tunnels and water flows, and you solve puzzles like with that. And game physics has also progressed from 2D to 3D, and large-scale water simulation is a kind of recent pinnacle of the evolution. So, physics simulation is a technical tool that has enabled a lot of novel gameplay and game mechanics, but now it kind of seems we can simulate everything, so where to go next? Well, physics simulation used to be CPU intensive, and it still is for complex systems, but we can actually now simulate simple game physics, such as a single ragdoll, even 1,000 times faster than real time. And in this talk, I kind of attempt a systematic exploration of what novel things can we do with this. To get started, let's now consider the role of physics and how we could categorize it and kind of map out the design space. So, one fundamental role of physics simulation in games is to compute the reactions of the game world to player actions. So you do stuff, things explode, and so on. But on the other hand, in AI and animation research, we are increasingly utilizing not just reactive, but predictive simulation. Basically, we kind of try different control strategies to the future in a predictive manner, then we select the best one and move forward, then we do more forward simulations and so on. And when you do this intelligently enough, you can enable things like this, that it automatically improvises climbing movements or walking on top of a ball or something like that. So this is our first design space axis, from reactive to predictive physics. However, that model, well, let's step back. What's kind of remarkable is that in both of these examples, you give kind of high-level command to the character. Okay, walk this way, or blow that up, or something. But it's missing this kind of games like WAP. Probably many of you have played. This was super popular at the time, although it's pretty old already. So the thing is that you have 4 keys that directly actuate the joints of the characters, and here you kind of play the AI's role and try to make it run, and it's just frustratingly difficult, but also absurdly fun. Yeah. So to incorporate games like WAP, let's add the second axis to the design space. So let's say we have this kind of low-level to high-level control abstraction. And now one of my main arguments is that what if we do the low-level control but with predictive simulation? Well, actually nobody has really done that. So that's what we kind of explore. Well, there's a few prior examples that I'll explain. So what does it mean? For AI, predictive physics can help to assess the outcome of actions and replan if currently planned action is not providing desired results. And considering the player in the AI's role, I propose now a second 4-quadrant model based on 2 key variables that affect decision-making and planning. As the first axis, I use the complexity of action. The more complex the player's actions, the more thorough planning is needed. And the second axis denotes pacing. So pacing interacts with complexity. If the game is faster paced, there's less time to plan, and even simple actions become difficult and might benefit from predictive information. And okay, this is the kind of design space model that underlies our work, and we have developed and evaluated experiments in all of these quadrants to see like what are the possibilities and challenges. And briefly about related work, of course, we stand on the shoulders of giants, like always in research. Laszlo and others in 2000 in Seacraft, they kind of presented the first paper on these direct control interfaces, basically the same as QoP, but in a research context. Then Twig and James explored this kind of trajectory visualization so that you can alter the starting conditions of a simulation and see how the trajectories change, but they only focused on the starting conditions. Then there's one particular game that inspires us. It's Tory Bash, which is a kind of physically based fighting simulator where you again control the character directly, but then it's kind of turn-based, that you say that, okay, now we will contract this, extend this, and then the player can say, okay, now step forward the simulation and then rethink and replan. Because we're mashing these up. So let's show the paper video so that we stay on time. So yeah, we kind of start with this Angry Birds style game, so that here the goal is to, for example, make the green cubes fall without making the gray ones fall. And we implement this real-time predictive simulation so that while the user is finding the shot, they can already see what will happen. And what that leads into is we can actually import and sample this action space and provide this kind of summary visualization or heat map. So that here, the horizontal axis is the angle of the throw, and vertical axis is the speed, and we see that there's these 4 different strategies that enable a good score. So bright color corresponds to good score. Yeah. Then another experiment, how about this kind of chasing, that somebody's chasing you, you have to get through the traffic, but it's hard. Well, let's do the same with prediction added. Here the player can press a key down to activate the prediction, and they will see the trajectory and also whether it will collide. And this gives them more time to actually go through it. So it's a kind of power up. And even more difficult cases, bike balancing and steering. So a bike, you basically balance using centripetal force. So if you want to kind of avoid falling this way, you have to steer this way, so that, or wait, yeah, it's kind of difficult to do consciously. And in our tests, if you map the mouse to the steering, it's super hard to stay balanced. But when you turn on the prediction, users can learn to do that without any kind of artificial balancing aids, which is usually used in computer games. Then, inspired by QoP, we did a few of these kind of predictive QoP versions. So here, basically, while you hold down a key, you see what will happen, and then you can kind of more thoroughly explore the action space, and then say, okay, now we step further. But it was still hard. Then we kind of moved on to this timeline version. So there's timeline tracks for each of these 4 keys, and you can actually paint the key strokes, their sequence, and see in real time how that affects the movement trajectory. And the kind of shadow character is what is happening at the time where the mouse is, and so on. So in effect, we are transforming a real-time action game into a puzzle. And so that's one of the nice things about this predictive simulation. And this is our final kind of bit more a real game. So if you played stair dismount, this is the inverse. So we have to save this guy. And we have the prediction, and then we have this kind of posing view, so that you can pose the character and then see what will happen in a moment. So if you make it tuck, you change the moment of inertia, and it will rotate faster and avoid hitting its head, for example. And then you can step the simulation forward, and then, okay, now it's time to untack and slow down the rotation. Okay, to recap, I first pointed out that although physics simulation has been extensively used in games and AI, the combination of low-level control and predictive simulation has perhaps been underexplored. Then I went on to propose this model that expands the possibilities of combining low-level control and predictive simulation. And the video showcased the prototypes we developed and tested. And I don't have time to go into the testing data, but basically, on the left, we explored these fairly simple action spaces. And the kind of typical feedback is that, okay, this makes the game too easy, but maybe it's useful for the level designer in, for example, testing the level and finding out whether there's a novel way to solve it or something like that, or playing beyond the level designer's level of skill. And then we explored these more complex actions, and this one was basically a failure because even though you could learn to balance, it still takes all your attention and you can't really drive where you want or play a game, so it's kind of tedious. It's not a meaningful puzzle, but basically testers all like this one, and it's interesting that here, even with the predictive simulation and this turn-based gameplay, the complexity of the human body still provides interesting challenges and enough complexity. And we also think this could be, this kind of epic saves theme could be extended to many other situations like here. Yeah, okay, that was all. So it's a kind of, my main message is that now physics is so fast that you can do it predictively. And what's interesting is that this wasn't possible in Unity, for example, because the physics simulation was tied to the rendering. So you couldn't step the physics forward without also rendering, and that's computationally inefficient. But now, in this year's Unity, so starting from 2017.1 version, you can actually do the prediction also in Unity. In our examples, we had to kind of plug into Unity our own customized physics engines and so on, but now it's really easy to get started if you get a game idea based on this. So, yeah, that's all I have to say. Thanks.
Awesome. I have one question for you. Alto recently launched this partnership with Supercell, and obviously there's a lot of gaming stuff happening here in the Helsinki scene. How is it in the other universities around the world? Are there any other kind of universities where gaming is a big part? Is Alto collaborating with any other universities around the world within the gaming area?
Yeah, we are. So, for example, that paper, so the fourth author of the paper, Julian Tokelius, he's from New York University, where there's also a really big games and games AI and graphics kind of concentration of really brilliant people. And then we are collaborating with RMIT in Melbourne, for example.
Very cool. And if there are students, one super last question while we're getting the things set up for the next. If students want, even if they aren't Alto students, can they still kind of work together with Alto or kind of get demos or get help with their projects or no?
Yeah, in particular we have the Games Now public lecture series that's happening every month in Design Factory. So those are open, and there's also a game jam as part of that, and also other game jams, and those are good for networking and finding help and meeting new friends.
Okay.
Create games.
Very awesome. Hey, thank you. Let's give Perttu one more round of applause.
Thank you.
Very good. Then we have another Alto showcase for you guys here today. The next speaker is actually a good friend of mine. He's also a previous Alto. He is active, has been part of the startup community here at Alto University for quite a while. Was studying here at Alto, and then we'll probably share those stories, but then in the end ended up actually going and starting his own company. And currently Varun Singh is the CEO and co-founder of callstats.io. It's a super interesting company doing a lot of really cool things. He'll probably share exactly what that is, but his topic will be more about how he jumped from the academic world into the startup world. Let's give Varun a huge welcome onto the stage.
Thank you. Thank you for inviting me. And so when I got this topic to speak about, I found it quite daunting because it's not easy to speak to a lot of people who are like just starting out. So I thought I'd just talk about how I walked through this over the last 10 years and maybe some lessons learned over that period. Just take this as a grain of salt because you can't walk on other people's footsteps usually. So when I started thinking about the talk, I thought about how I did it, and I think this quote from someone else actually covers the aspect really well, because so if you have a long-term vision or if you have a mission that you want to achieve, when you're younger you say, this is what I want to do, and to achieve that you can't actually start off doing that from day one. So you have to go after something smaller. And in my process, or in my last 10 years, I've actually meandered through life. Basically, I've gone left, and then I've gone right, and then basically gone back left. So I'll just walk you through that, and then basically talk about the things that are inspiring us today. So today, the mission this year in 2015 through 17, the vision for me or the company has been to be able to build a real-time communication platform or service to help people build frictionless products. So that basically means that we should help them set up, operate, and scale those services so that they would be able to achieve whatever they want to achieve. So today you have companies like Snapchat, you have Instagram, they're all using videos in different ways. And we also think about other issues like healthcare, online learning, education. They're all moving to video so that they can teach the people or solve really difficult problems with healthcare in a very seamless way. So in 2014 or 15, when I started thinking about it, I said, okay, we want to do this. This is my mission. How do we do it? So I came up with this philosophy that we would do continuous monitoring. So we would be able to detect, diagnose, and deploy issues in real time. And when I thought about it, we actually did not have much of this really in place. We knew that we wanted to do it in real time. We had some ideas of how to detect things. We actually did not know how we would deploy. But the vision from day one was to talk about all three aspects of it, even though we could not do almost 75% of it at that time. So I'll just talk about the mission and then basically what we did to enable it. So basically, we started in 2014 a company called CallStats. It was 4 founders, so found people to embark on this journey. And then we raised money over 2 rounds of funding, 4 million euros. Last of it was 3 million last year, 18 months ago. And today, there are about 300 products that use CallStats. And so just to go back in time, I would just say, how did we do it? So I moved to Finland about 11 years ago. And one of the things that I moved here to do was basically start my education. So I did my master's, and then I did my PhD between 2006 and 14. So basically started to get some of the things that I would need to build this company as an education process. And then in 2004 through 2012, I was part of the startup community. I got my first job right out of school. I did a couple of startups, so I actually had a learning experience. And then to solidify this, to bring these 2 things together, in 2010, I started working with standards. And standards are just organizations which basically try to standardize things. And in this case, I was working with people from Google, Cisco, Nokia, Ericsson, so some of the biggest telecom providers or equipment providers in the world. So if you put all this together, it's easy to see why in 2014 I would come up with this idea to build CallStats, because I had some of the building blocks which were independently built, not necessarily in any grand vision, just randomly put together. But then I had all the tools to build this company. So the next part of the talk is basically about the 4 lessons that I learned. So one was follow your passion. And part of that following your passion is to actually exploit whatever you're going to do very well, exploit that. So instead of, people talk about being, learning about other things, that's all cool. But if you're good at something, then be very, very, very good at it. And if you're very good at that, then you can exploit it. And in my case, it was the 3 facts that I had. I had a community around me, I had the technical knowledge, and then I had the people that would be able to guide me through that. So, and once you have this passion, then you need to start talking about it, because you have to tell people about your brilliant idea so that you can gather feedback. One of the things that I've noticed over the last few years is that when people have really smart ideas, they actually stop talking because they feel someone will steal it. But actually, the only way someone can steal it is they would be executing faster than you. So the only way you can actually win any game is actually execute faster than anyone else, but keep telling everyone what you want to do. In that process of telling people what you want to do, you actually get feedback from them. And that feedback's really important, because whatever your initial idea was, it will transform when you talk to other people, and they'll give you insights. Because not everyone has the audacity to do what you're doing. So if you're already saying that you're doing, people are like, okay, actually I can jump onto your ship instead of trying to compete. And the other thing is that at the end of the day, you want to take this product or service to your customers. So you should start talking to your customers as well. Even though you do not know if they'll buy it, you do not know they would buy it from you because they do not trust you, or maybe they don't even think you're smart enough to do it. But telling them about it all the time also means that they will start giving you feedback. And if they keep hearing the same idea from the same person over and over again, that's kind of charming for some people. So it works. And lastly, nothing's possible without a team. And so team's really important. And in my case, it was when I had the idea and I started talking about it, I got 3 people super excited about it, and they joined me in this journey. And that's been super helpful, because 1 person can only do so much. 3 people can do a lot more. And then today we have 20 people or 25 people, and we as a collective group can do a lot more than we could like 4 years ago. So just to summarize, the things that I think the lessons I learned were: follow your passion, exploit your whatever is the thing that you think is the most important thing. Then secondly, tell your idea to everyone. Listen to what feedback they give you and build a team around you. And that's about it. We're also hiring, so if you're looking for a job, then we have all functions, both business and engineering, looking for new talent. So if you're interested, just drop by. You can also write an email to us, varun@callstats.io, and that's it. If you have any questions, be happy to take them.
Now, at this point, okay, I have a few. Let's start with Junction and the weekend. I mean, from your point of view, what would be the coolest shit that somebody could build during the weekend?
Actually, today, I think the coolest things that you can build are like mashups, right? And it was true even like 10 years ago. 10 years ago, mashups were about web APIs, but today it's about like technology. So you can take AR, you can take machine learning, and you can take VR, you can mash them all together. You can put video, you can take, again, like you could build Snapchat in like a few hours today, because you can take a camera, you can take the feed out of the camera, you can detect people, their faces, and then you can do masks, like pretty much straight out of the box. I'd love to see someone do this, and my hypothesis is you can do it in 6 hours.
Nice, nice. Well, you already said that you're hiring a lot of people. Why is that? What's kind of the next phase for the company?
So for us, what we've seen in the last few years is that video is becoming bigger and bigger. As in, you've seen Snapchat, and it went public in the amount of, like 3 years. It took Facebook 8 years to go public, and Snapchat did that in like half the time, right? And you see video as like a core component of that. So in social, in consumer apps, video is really big today. We're seeing that actually go across the field. So you can see things like in insurance, you can see like you have an accident today. You can take videos, you can get onto a call with your insurance agent, he'll capture that video, and then it's part of the discovery. We had this banking thing before, and they said, know your customer is so important. And that today, like in Germany, happens through your browser. You talk to your bank right through it. They confirm your identity directly. The iPhone 10 the latest one, you unlock the phone using your face, right? And that's just video and AI on top of it. So video is big these days.
Nice. So you seem to be kind of going towards the right direction. The market is going to be growing.
It is growing.
Exponentially.
Yeah. Alexa, that's another thing, right? So
Yeah. Then last question. I'm personally super annoyed always with using different video conferencing softwares.
Right.
And most of them are completely very not so good. Why is that? Why do you see, I mean, you've been doing a lot of audio stuff and now kind of doing more and more video, but what's kind of the fundamental problem with having video on the internet?
I think diversity is the biggest problem. We have like diverse number of devices, diverse number of networks, diverse connectivity, right? And if you put all that together and you still want a seamless experience, that's super hard. That's a difficult problem. And you want it everywhere in the world. So you go to India, you go to Africa, you go to Sao Paulo, you go to like the Andes, wherever you go, you want like that seamless experience. And that's really hard to deliver all the time. As in just delivering it in San Francisco is difficult, so.
That's a good point. Okay, now I understand slightly better. Awesome. Hey, let's give Varun one round of applause for the awesome speech. Super. And from now, we'll have a very short break. So if you need to hit the bathroom or need to go and get some snacks, you have time to do that. And then we'll continue here in about 10 minutes.
6.
So, yeah.
Everything's fine?
All right. So that was a very quick break. And now we'll continue with the program here on the stage. We have a bunch of more awesome keynotes for you guys here today. We'll have one more Alto showcase. So again, a story from the Alto ecosystem. And like I said before, AI is one of those super hot topics today, and then the other one was machine learning. And surprisingly enough, the next topic will be about machine learning and how that, what all different types of things that is enabling. And for the next, I would like to invite up onto the stage Mika Juuti and Andrew Paveyard to come and talk about their topic.
Thanks very much.
Thanks.
Good afternoon, Junction. Nice to be here. My name's Andrew, and this is my colleague Mika, and
Hi.
we're from Aalto University's Department of Computer Science. So, let me start with a question. How many of you think machine learning and AI is awesome? Show of hands. That's the entire audience. Brilliant. And welcome to you guys on live stream as well. What we'd like to talk about today is something slightly different. AI is awesome, we all agree. Machine learning is awesome. But what happens when you have an adversary? What could possibly go wrong? So, quickly a little bit about us. We're from the Department of Computer Science here at Aalto University, a very highly ranked department, specializing in AI, algorithms, and security and privacy. In particular, we work in the secure systems group, so we aim to build systems that are secure, usable, and deployable. My name is Andrew, as I said. I did my PhD at Oxford, and since then moved to Helsinki, and my colleague Mika is a PhD student in our group. So there are all of the web addresses on the screen, and if you go to my website, you can find all of these slides, so you don't have to try and click the link on the big screen behind me. So, I think nobody would disagree that machine learning is ubiquitous. It's going to be used in more and more startups. It's expected to grow 44% annually over the next 5 years. And last year alone, companies invested up to $9 billion in this industry. So nobody's denying this is great. And machine learning has often been used for these sort of security and privacy applications. So think about access control, recognizing, is this Andrew's fingerprint or Mika's fingerprint or somebody else's? Think about iris recognition. Machines are really good at recognizing patterns in our irises. Things like malware detection are very commonly used as applications of machine learning. But what we'd like to talk about is a slightly different twist, the security and privacy of machine learning itself. So let me give you an example. What is this? If I were to ask an image classifier, what type of image is this? Anybody from the audience? It's a bus, absolutely. It's a school bus. But if I apply some, let's say a transformation to it, this weird pattern in the middle of the screen, the image on the right, now, what is that? But now it doesn't look like it's really any different. So you're suggesting it depends what class I specified when applying the noise, but really I want my model to still classify this as a school bus. Turns out this is not a school bus, this is an ostrich, according to the machine learning model. I hope everybody in this room sees this is not an ostrich. How about this? This, I think we can all agree, is a panda. If I apply a similar transformation to this, what is the item on the right-hand side? This, ladies and gentlemen, is a gibbon monkey. So let's try one more time. What is this? This clearly is a building. But if we apply another transformation to it, this is, again, an ostrich. And so this is an example of how a machine learning classifier has failed by some imperceptible changes to the input. You can't tell that this is different, but this fools the classifier. Okay, you say, Andrew, you're cheating a little bit. This is a static image. We would never have this if I could maybe look at the image from a different perspective, or if this is an autonomous car that's going to see an image while it's moving. So how about this? This clearly is a cat. This is a picture of a cat. However, when we ask a machine learning classifier, it says this is actually a desktop computer. When I move it around, have a look at the classification on the right-hand side. Even though the picture is zoomed and rotated, the classifier is still calling it a desktop computer. Ladies and gentlemen, this is evasion of machine learning. This is a big problem. But enough about cats and ostriches. This is one example. What about something else? How many of you know about Siri and Google Now? Brilliant, you all have Google or Android phones. If I were to tell you that I could control your phone using some sort of inaudible voice command, listen to this.
Hey Siri, call 1-2-3-4-5-6-7-8-9-0.
So that was a normal voice command. Siri makes the call. Now you need to be really quiet and see if you hear anything. Siri's making a call. Using ultrasonic sound emissions, they were able to trigger this property of the machine learning model on the iPhone in order to make it do something. Imagine the possibilities, because you can't hear what your iPhone was just told to do. So that was another example of evasion. Let me give you one more example now about something we call inversion. Imagine I have a machine learning model, and it's trained to recognize this person's face. So you can ask this model, is this the particular target or not? Now, normally this shouldn't reveal who the target is, but researchers have shown that by asking intelligent queries, you can actually, using different techniques, start to really learn about what training data was used in your model. So if you were planning to use machine learning for a privacy-preserving system, this is something you need to take into account. So with that, I hand over to my colleague Mika to give us a more theoretical underpinning of all of this that we've just seen.
All right, so I'm fairly confident that all of you are somewhat familiar with machine learning by now. So this might be a very basic machine learning pipeline. Data owners are contributing with some data to some kind of system, and let's see. The analyst can get some kind of information from that kind of system. In this talk, we'll talk about a little bit more realistic pipeline. Data owners are contributing to a data set, and in here, the data set is fed to a trainer. The trainer is somehow using some kind of machine learning model to build a classifier or other type of system. The analyst is here specifying to the trainer what kind of system is going to be built. It's relying on some third-party libraries, for example, TensorFlow or other machine learning libraries. The end result is a machine learning model that is aimed at doing some specific task. For instance, predicting what would be the next word or classifying ostriches and gibbons. The client is usually in contact with the machine learning model here, and he can send some queries to the machine learning model and get some responses back. And in certain cases, you also have a prediction service provider API, where you force the client to go through the API in order to get the queries. The question is then, where is the adversary? And they can be in a lot of different places. Let's start with the first case. So what can the adversary do if he is one of the data owners? How can he influence the model? The data owner can influence the data set, and through that, the machine learning model itself. Recently, 1 year ago, this has shown to be a problem in the chatbot by Microsoft. I'm sure you all remember Microsoft chatbot Tay, which was supposed to talk to teenagers over Twitter. In there, inadvertently, the data owners were able to manipulate the machine learning model to provide sexual or racist comments to client queries. So for instance, here, the client is asking, did the Holocaust happen? And Tay is answering that it was made up. So this is clearly not what the analyst wanted Tay to do. And very recently, YouTube Kids channel was shut down due to it providing violent and harmful images, videos to small children. So influence on the machine learning model through data owners can be a really big cause of concern. We can also consider that the third-party libraries that are in use by the analyst might not be entirely trustworthy. Recently, researchers showed that it's possible to leak secrets through the machine learning model if you're using third-party libraries. In here, the analyst was training the classifier in ordinary ways, but the regularizer term was modified in such a way that the model parameters were incorporating data about the input. So the threat here is the privacy violation. And the machine learning model might reveal data to certain clients. Prediction service APIs might also be a cause of concern for clients. Think, for instance, that the client wants to classify whether a certain web page contains some explicit content. If he's worried that the prediction service provider can't be trusted, that may be valid. It might be used for user profiling. And as you saw earlier with Andrew's slides, the client might also be the cause of the adversary. So for instance, imagine a system that tries to classify road signs. And these are already in use in autonomous driving scenarios. So the client has some kind of input image. But he is able to modify that input image in small ways. And that can fool the machine learning model to output something entirely different that was not expected by the analyst. So this is called model evasion. But that's not the only way that the client can try to learn or somehow influence the machine learning model. He may also, as Andrew showed in the last slide, try to infer some properties of the data set or about the data owners. And this is called either model inversion or membership inference. So with these queries and by analyzing the structure of the machine learning model, the client can construct his own data set of what the input data was likely to look like. Finally, we can think of an adversary that is trying to steal the machine learning model. And this can be done by repeatedly querying the machine learning model, getting the queries, and then trying to reconstruct such a model that answers those queries in the same way. So this is called model extraction or model stealing, depending on the source. So in these scenarios where you're worried about adversaries, please think about what kind of capabilities you're giving to the adversary. What does it mean that the adversary can freely query the machine learning model? And what does it mean that the adversary is contributing to the data set? So we're working on these problems in the Secure Systems lab. And if you have any problems or questions, come talk to us. I'll give the mic now to Andrew, and he'll talk about Seclo for a short while.
So just one further announcement then, if you are interested in working with us on these sort of problems, and you're an aspiring master's student, we've just recently announced a joint master's degree program between Aalto University and a couple of European partner universities, where you have a joint degree between these two universities. Now, applications open really soon, in a couple of days, and there are many scholarships available. So if you're interested in something like this, please do come and talk to us. But as Mika said, we're also more interested in this general area of machine learning in the presence of adversaries. So if you're using machine learning, this is something for you to think about. If you want to do research in this area, come and talk to us. Thanks.
Cool. I have one question for you guys. So you're both from technical backgrounds, right?
Yeah.
What would be the coolest shit, again, that people could build during the weekend, in your opinion?
Well, since we both come from a security research group, we would be interested to see if anybody is using machine learning, can you do something that has a security application? Can you do something really cool that helps to solve the security challenges of the world that we're facing? Spam emails, phishing, ransomware. Can you use machine learning to solve a problem like that? And can you do it in a robust way that you're not vulnerable to some of the attacks that we're shown? In other words, can you build a classifier that calls a kitten rather than an ostrich?
Right. And then, I mean, there are, like Varun said right before, there are already a lot of like libraries and different APIs and SDKs and whatever that you can use. Do you see that you can actually, using the modern technologies and tools available, can you actually build something that's like robust in a weekend, in like 6 or 12 or 48 hours? Or does it require actually spending a lot of time and doing testing and, you know, figuring out, are there vulnerabilities in the software that you're making?
Right. So at least you can. Often in these scenarios, what is really important that you have some kind of way of assuring that it's actually doing what you expect it to do. That may be a challenge, but if you can do it in 48 hours, that would be really awesome.
That's why people are here at Junction.
Exactly. Awesome, man. Let's give the guys one more round of applause.
Thank you.
Super. And then we'll continue on with the program here on the stage. Next up, we'll actually have an interesting person. And he's representing an organization that is in a way kind of the grandfather, in a way, for at least, I would say, the hackathon culture in Finland. In a way, not like directly, but in a way. So Assembly roots trace back to the early 90s, and it was back then when a group of people from the demo scene came together and organized the first events. And since then, Assembly has actually been a catalyst for a lot of the huge gaming successes out from Finland, including Rovio, Supercell, and Remedy, and a lot of other companies that have grown out from this area. And now Jussi will be talking about how Assembly has actually been at kind of the forefront in the Finnish demo scene, and how that has affected the demo scene and the game scene in Finland. Let's give Jussi a warm welcome to the stage.
Hey. Hey, thanks everyone. Nice to be here. Let me get the show on the road. So here we go. So thank you for the kind introduction. Said my name is Jussi Laakkonen. I'm one of the 2 main organizers and co-founders of Assembly. Coming here, I had a moment that I thought I would never happened to me that I met a 20-year-old volunteer here at Junction, and he asked, like, what do you do? Well, I organize this assembly. And it's like, what is that? So I thought that given some of you actually might not have been there, if you're nerds, and they're Finnish, I kind of think you probably have. I thought it would be great to open up with a video to show you the journey we've taken over 25 years and show you a glimpse of what the demo scene is. So let's roll the clip, and let me just first make sure we have actually audio on, because I think I turned it off. Here we go. And let's see how this plays. And hopefully we get audio. Here we go. So while we started in 1992, and the computers were smaller, and the tellies and the monitors were bigger, assembly has been kind of through these roots for about 25 years. It's still a bunch of nerds coming together to have fun, get away from the sun for 4 days around the clock, enjoy your company, and create something incredible. And this is what we are really all about. So what we looked at was a demo from a group called Andromeda Software Development. And demo is a short for word demonstration. It's a demonstration of your skills as a programmer, as a graphician, as a musician, as a group coming together to create something that runs on real time on your computer. This was not a video, it was computer-generated graphics. And this is where the demo scene comes from. It's all about what you can do in real time running on your computer and turn it into an art. It's about astounding visuals by a group of hackers, hobbyists, and people who think they can want to create something astounding and break the barriers of hardware, technology, and express themselves. So demos are the art of real time. Now what is assembly then? It's a demo party, which basically means coming together of people, like-minded people who make demos, who like demos. And that's where we started in 1992. Like that still continues to be at the heart of assembly. This competition, this showing off, this what is it going to be the next awesome thing that people create. But we are about a lot more, as you saw there. We're about dancing dinosaurs, we're about esports, we're about just hanging out and having fun. So we've been running for 25 years, and I think that's actually longer than some of you have been alive. So the monitors were definitely bigger in 1992, but it was about the same spirit, and a lot of this that's still here at Junction. It was coming together, programming to the last moment of the deadline, putting out what you created, and showing off other people for to be voted and maybe win fame and glory. Now, we've organized over 37 events across, starting in schools, then going up to places like the Hardware Arena, and now at the Fair Center in Helsinki. We've also taken a detour to Tampere for a couple of years, but now we're all back in Helsinki, also with our winter events. So we do events twice a year nowadays. Over this time, there's been several thousands of demo scene productions created at Assembly. People have come to Assembly to compete, to release something they crafted to the world to see. And what I'm super proud of, that over these 25 years, over 150,000 people from Finland and abroad have come to Assembly to spend several days together with their friends, maybe make new friends, some of them to compete, some of them just vote and have fun. But I can say we touched so many people and given them a place where they can feel awesome being a nerd, that we have made a positive contribution to the nerdy part of Finland. And we started this simply because we wanted to have it for ourselves. Assembly is a volunteer organization, just like you could call Aalto ES or Junction. We're about 25 to 250 people running this for the hell of it. So what is assembly? And as I alluded to in the introduction to the session, assembly is really not the demo scene. It's not the talents. It's not what you see on the screen. Assembly is a catalyst. It's like Junction is. It's like what you come here and create something. Junction isn't the one creating it, but it creates this atmosphere. It accelerates the reaction of coming together. So I see assembly as a catalyst. It brought together people, and it made those things go faster. And in doing so, it also was kind of a focal point, because you have this point in the year, and if you really want to be on the top of your game, you want to be seen by other people on this planet who like this thing, you have to focus and you have to come together, and you find the other people who are also interested in the thing. It brings people together, just like Junction does. It was also a forcing function, because a lot of the times people will talk about doing something great. But when you have a date, you have other teams coming and competing, and you want to be on your best, it forces you to actually put on your best, work together with the teammates, and figure out ways to solve things on a deadline. Those are great for forging teamwork skills. They're great for learning. They're great for actually getting a self-discipline of running things. So I want to tell you a really awesome story on how the demo scene and assembly affected a really extraordinary outcome here in Finland. So let's take a look at the demo that won Assembly's Amiga demo competition in 1996. So this demo was created in a machine called Amiga, which was beloved by the demo scene and was really a awesome machine. This ended up being the last demo of a Finnish group called Virtual Dreams. And what is a group? It's a group of people. A demo group is the people who make demos. They have programmers, designers, graphics, musicians, and producers, and they work together to create something like that in, well, 21 years ago. So what happened with this was the last demo of this group, but they forced some really interesting skills here. And a couple of years after this demo came out, they had been thinking about doing something together, and with a couple other friends, they started a company, which they picked a good name for, Sumea, which is the same name as the demo we just looked at. So I started making mobile games. This was in early, actually, I think 1999. And they made actually really good success here in Europe back in those J2ME days. Eventually, they merged with a company from North America called Digital Chocolate. Digital Chocolate eventually went away. They didn't do really that well after like 6-8 years later, after taking a foray to Facebook. And a lot of these guys, some of them who were still involved in the demo scene, took a break and said, like, you know what? We actually like making games together. And they started a company that became the Finnish Deca unicorn. And you can actually trace the founders of Supercell right back to the demo scene. So people like Visa Forsten, who's one of the founders, still continues to come to Assembly, to Boo Assembly, and hang out, because that's where he grew up. Now, this is not to say at all that Assembly made Supercell. No, not at all. Not at all that Junction makes the next big startup that happened to come here together. But these things are extremely important because they create a culture of working together under a timeline as a catalyst that forces things come out of you that you otherwise would not. So I want to leave you with inspiration. Now, we're here at a hacker event. This is all about making something incredible with your code. So I want to show you something incredible. One of the specialties of the demo scene is what we call size coding, which is how much can you fit into, for example, 4,096 bytes. So 4 kilobytes. Most of your emails are longer than that, especially if you use a little bit of HTML soup in there. So I want to show you a demo called Final Stage. This runs in real time on a modern PC, fresh install of Windows, nothing else. You download the file, you hit run, it's 4,096 bytes. With that, I hope you'll enjoy this and you'll find some inspiration for your next hacker thing. So let's check out Final Stage. So if you want to find more awesomeness, you can check out those links. With that, I want to thank you for listening to me talk about assembly. Thank you. And I guess we have time for questions, if there's any.
Yes, any questions from the audience? I always have great questions, but does the audience have any great questions at this point? No? Okay. Well, then, my first question. If I don't know anything about programming, or I haven't done a demo, how hard is it to start?
Well, to get to the point of making a great demo nowadays, actually, it's kind of sacrilege to say, but you can actually make a demo without programming. It's kind of a cheating, but you can. We've increasingly seen graphicians and musicians start using a tool called Unity, which is a game engine, or Unreal, but Unity seems to be a little bit more popular, and I happen to work there. And they actually started doing demos around the visuals, around the feeling, without having a programmer. So it's actually completely doable. And there's even a seminar, if you go to Assembly TV on YouTube, you'll find a seminar from this year where a graphician who's not a programmer shows you how to create a demo with Unity. So if you want to create those visuals, but obviously if you want to get the real experience, you have to be a programmer. So I wouldn't say, if you're a graphician or you're a producer, a designer, be good at what you do. But if you wanted to make demos, you can also make those with a tool that you don't have to program with.
Okay, awesome. So that's a great piece of advice to anybody in the audience who thinks that, or who really would like to build something awesome that we just saw there. Hey, let's give Jussi one more round of applause for the awesome presentation. Super. We're going to continue with very technical things. Next up, we'll hear about how to actually get into the nitty-gritty details of actually deploying an app. And for this, I'd like to invite up onto the stage Jonathan Mägi, who's the technical lead at an Estonian company called Move Guides. Please give Jonathan a warm welcome.
So, hello all. I'm Jonathan from Move Guides, and it's not really an Estonian company. It's a global company, as more and more companies are these days. We actually have headquarters in London and San Francisco, and a team now in Tallinn. A team that actually joined via acquisition. So I used to be the employee @1 at Teleport. Now being part of Move Guides since April. And at Move Guides, we're building a platform for global mobility to help Fortune 500 companies move their employees. And as we have customers from financial industries, technology industries, everywhere, we are more and more thinking about how to securely and reliably run our software. And that brings us to our today's topic here. But I thought, like, just talking about cloud-native solutions in a hackathon might not be the perfect use case. So I thought, like, is there something cool that we could do with Kubernetes and Google Cloud, for example, some of the technologies that we use at Move Guides as well, but move fast, and not build something huge, but get started with something that would be even usable here in the hackathon scene. But first, what is Kubernetes? Kubernetes is end-to-end solution to manage your containerized applications. And it's definitely not scary. You shouldn't be afraid of using it, even though it does pretty much everything you want it to do. It's immensely extendable. You can even change the very low-level details that it includes. Also, why not to be afraid of it? It's definitely production-ready. And it's not only for microservices. You can take your existing running monolith application, deploy it on Kubernetes, and already get some awesome benefits from the platform. And then Google Cloud Platform, the other pillar that we will be building on top today is just another cloud platform. Like, there's no real difference from AWS or even Azure. But why it's special and then useful in this case here is that it's today offering one of the better managed Kubernetes offerings. And it has very friendly pricing, so you don't have to pre-buy your instances or anything like that to actually benefit from good pricing. And it can grow together from prototype to planet scale with you. If you get started on Google Cloud Platform, initially you get $300 worth of credits. You can spend these as slowly or as fast as you want, but in addition to that, there are many free tiers there that can help you get started. So Kubernetes, launching the cluster actually really is this easy. You just go to the Google Cloud Platform dashboard, you fill a few fields there, you define the cluster name, where does it run, what's the version, and how many instances of which size does it include. Command line, of course, gives you even more power over configuring it all. You can deploy it into multiple availability zones to make it highly available. You can tune everything that's necessary there. But what you don't have to worry is about managing the cluster as such. You don't need to worry about patching the instances, doing software upgrades, or anything like that. And the thing that we'll be using to actually ship the software today is Google Container Builder. And it's a building pipeline. You can think of it like Jenkins in a cloud if you want to, but it's quite different. It's fully managed as well. Again, for the hackathon, you can actually pretty much use it for free. It includes 120 free build minutes per day. It will support triggers to automatically run on the code changes that you do. You can define your own build steps, and all the build steps are actually just the Docker containers running on the build. And it integrates nicely with all the other Google Cloud Platform services, and it's fast. And here as well, like easy example how to define a build trigger. And it's not only supporting Google Cloud Source Repository, it's supporting also GitHub and Bitbucket. So in most of the cases, your code is hosted on one of these. You can get easily integrated and then start your deployment processes by just pushing code. So for our example, we have a simple Go application. It's a single file, main.go. You can get it from my GitHub repository if you want to take a look what the other files there are. The interesting bits here are the .kubernetes folder that includes the deployment specification, ingress specification, and also service specification. Very simple YAML files. And it also includes cloud-build.yaml file, a YAML document that actually defines our build steps. So here we can see that we're building the Go application first. We are building that Go application that we just built into a Docker container. And then it includes many, many other steps that we have integrated here to actually ship it on Kubernetes. And the final deployable asset here will be image deployed to project using the repo name that came from the GitHub. So when we push to GitHub, we want to also see what's actually happening there. So Container Builder provides detailed build history, and then you can have always a real-time look into what's actually running, what's happening, what are the commands being executed, and then what's their results. But let's get to a demo. And I thought that maybe I'll do a live demo, but I actually sat in the last row and did some screenshots for us. So I have actually deployed this application. When sitting in the last row, I booted up the cluster. The booting up of the cluster takes around 5 to 6 minutes. It, of course, depends on the size as well. And I hooked up a DNS. So if you go to hackathondemo.space, you can actually take a look at the application running. And it was returning hello world if we curled it. So doing a small change, and then changing the simple Go application to return something else. We commit, and we push. And this is very similar how you get started with something like Heroku. But this, in the end, will give you much more power on how to continue building your application if you outgrow the basic Git-based deployment flow. So here we can actually, in a command line, take a look at what's going on. We can see that there have been previous builds. I'm listing the last 5 ones. And then you can see that the latest one was still working on this screenshot. You can see the output of the actual build. You can see the different build steps running. And as I mentioned, like all the build steps are just Docker containers. So it gives you immense opportunity to do whatever you want in these build steps. Here, one of the build steps, I'm modifying the Kubernetes deployment YAML file to include the latest SHA of the Git push to reliably roll over to the next version. For that, I didn't have a solution out of the box in the container builder, but I built a Docker container that included env-subst, and I just took environment variables and replaced them into the YAML-based template using that container. And when it has succeeded, we can see that, yes, actually the new pods are running as well. And then the pods are the building blocks of Kubernetes. And these actually run our containers. So we can see that 2 pods are running, and then we can see that the application actually was indeed rolled out and deployed. So this gives you a chance to build on top of Kubernetes, but ship as simply as you could do on Heroku or any other platform as a service provider. And of course, as everyone else, we are hiring. So if you want to solve interesting microservices challenges with us in Tallinn or in one of the other locations, then take a look at what we have to offer. And that's it. And if you have any questions, I'm happy to answer.
Super. Do we get any questions from the audience? Now, this is very technical stuff. You might actually have questions regarding this. No? I guess they're just so smart that they just get it like
Of course.
on the first try.
Maybe one question?
Yes, just a second.
So you mentioned in the beginning that kind of even if you have a monolithic application,
Yes.
then using Kubernetes cluster can still have some benefits. Maybe you went kind of through some of them here, but I didn't maybe really internalize like why would I use that instead of just having a
So first,
way of deploying?
just taking your monolithic application and containerizing it can already give you some benefits. You take the configuration out from the application itself, ideally. And then Kubernetes helps you manage that configuration, for example. So if you roll out to different environments, you're still rolling out the same application container. You don't do any changes to the code there. But what you do, you change the configuration of that environment. Environment defines the configuration. That's definitely one thing. Another thing is that building on top of Kubernetes would allow you easily to do canary deployments, A/B testing between different versions of your application. You don't need microservices for that. You can do A/B testing between 2 monolithic application versions and then just targeting traffic differently on top of that. And it handles all the rollout issues for you as well. So you just push a button, one instance dies, another comes up, next one, next one, next one. So gradual rollouts.
Super. My question would be, again, what would be the coolest thing that you see that somebody could develop during the weekend?
So as we talked about orchestrating container applications, and many people have been talking about machine learning and AI and stuff like that, and something that I'm myself been pondering a little, and I know that there are definitely enterprises doing this, is actually doing predictive scheduling. So you learn from the usage pattern of the actual cluster. You can start predicting how many nodes do you need, can you scale down, can you scale up. This would allow you to cut costs and be always available when you need to.
And you think that could be done in like 48 hours or?
On top of Kubernetes, I think this could be done, yes.
Okay. That's, I think, a challenge for the guys out there that maybe if you're good enough, you could.
If anyone wants some tips, then I'm available.
Awesome, awesome. But hey, let's give Jonathan an awesome round of applause for the very technical speech.
Thank you.
Great. Then we have a few more very interesting things happening here on the stage. Next up, we'll hear from the guys at BlackRock, which is the world's leading and largest asset manager guiding individuals, financial professionals, and institutions in building better financial futures. And the cool thing is that the guys were also partners last year and they came back. So apparently they really had a great time here. But without further ado, I would like to invite to the stage to talk about developing technology at BlackRock, Dilip Buddha and Bodgan Guna.
Thank you there. That's a good introduction. So, hello everyone. How many of you here, just a quick raise of hands, how many of you here have heard about BlackRock? Anyone? There's some. I know you know BlackRock. So we're here from BlackRock. Let me just quickly introduce ourselves. I am Dilip. So I work as a software engineer in the Web Tools and Technology team.
And I'm Bogdan, and I'm also a software engineer, and I work in core software infrastructure.
So, what is BlackRock? BlackRock is an asset manager. It's a fintech company. By asset manager, we're sort of away from investment banks or your normal banks that you see in your high street shops, in your high streets. So BlackRock is an asset manager, but at the end of the day, we invest in money. We invest in money in order to get a better return for our clients. Who are our clients? Our clients can be pension funds, rich individuals, companies, or even governments. So a company has a lot of employees, and all of these employees have pension that they want to get money in 50 or 60 years whenever they retire. And that's where BlackRock comes in. Invest in that money so that 50 or 60 years down the line when you retire, you get a better return. BlackRock is the biggest company that you've never heard of. How is it big? Because we manage about $6 trillion in assets in AUM. So,
sorry, Dilip, sorry, but what is AUM?
Good point. So AUM is assets under management, as the name says. That's how much money that we have. That's how much investment that we've done for our clients. So that's how much assets that we have under our management. And our revenue is about $10.95 billion. So that's a large amount. We have about 15,000 different employees, and they're in 70 different offices in 30 different countries. So in the sense of BlackRock, we have technology. So we'll build a product, and that product has multiple components around it. And these components are important, and these are the components that you see here. So these components, all of these components have three key main themes, which is we need to make sure we design them well, we build them well, and we actually run them well in stable environments. What is this product that I'm talking about? So this product that we build towards is called Aladdin. What is Aladdin? Aladdin is an ecosystem. It contains a lot of different applications, from trading, from reporting, creating multiple reports, or even creating risk, knowing more about the risk that you've invested in. So there's a quite big range of applications that live within Aladdin.
So because we are part of such a sensitive industry, we are not allowed to have failures, we are not allowed to have downtimes. So everything needs to run smoothly at our clients. For that, we need to make sure that we have a strong infrastructure and an underlying system that supports all of these products, that supports Aladdin at our clients. So we need to make sure that we deliver the code, deliver the products, and that they all run at all times.
So we have to keep it stable, but at the same time, we want to give our developers the freedom to experiment any technology that they want. So this is some of our stack that we use in BlackRock. And we want to make sure that we build a product, we build our product in a really good way using the technologies that we want to experiment in.
And not only that, we offer our developers the opportunity or the chance to develop code in their favorite programming language or to use their favorite tools and editors. We need to make sure that we use the perfect tool for the product. We need to make sure that we use the right thing all the time. And because we are here and we are at a hackathon, just to remind you, we are also hiring. So
you can find us on careers.blackrock.com. We have quite a different varied schemes that we provide. So if you're graduating in 2020, there's Spring Week, which is a 1-week internship. If you're graduating in 2019, there's a 10-week internship, summer internship, and there's also 1 year or 6 months placement. If you're graduating next year, if this is your final year, and if you're graduating next year, We've got the graduate program where you rotate, where you're there for 2 years, where you're working for 2 years, and you rotate into different teams every 6 months. We've also got the experience hire, so if you've already graduated, we do have some roles as well. So if you are experienced hire, do come to us, talk to us at our store later on.
Also, to add to this, Dilip and I have been part of the graduate program. We finished it a few years ago, and now we work as full-time software engineers. Also, just a quick reminder, we're still doing the Capture the Flag challenge. So if you want to get your hands off one of our backpacks, please follow the link on the slide and complete the tasks. And
we've already got one winner already, and because this Junction is the biggest hackathon, we've got more gifts to give you out. All right, so now we've talked about BlackRock. Let's talk about the technologies. How do we develop technology at BlackRock? What are the different processes that's involved? So everyone in a hackathon or everywhere, people tend to focus on just the coding, just the developing concept. But there's a lot of processes that revolves around this developing, around coding. And this is something that when I was in university, when we were in university, we didn't know about it. And when we joined BlackRock, we learned about this, and we felt that this would be good to talk about in the presentation in a hackathon. And this can be applicable to you now, or maybe in the future. But at some point, as a developer, this is definitely applicable. So the methodology, there's two big methodologies that people look at. One's Agile and one's Waterfall. So those are the two main methodologies. If you take a step back, that's where we look into.
So taking a look at Waterfall, the name is very obvious. Basically, you have all the stages in one row, and you execute them till you finish the product. So you start by gathering the requirements, then designing the product, then you continue with developing the product, writing the code, and in the end, you finish with testing and, of course, deployment. Why we personally don't think this is a good approach, especially for a hackathon, is that let's say you have a team of 3 or 4 developers, and you have a brilliant idea on how to revolutionize the day tomorrow. You have something very innovative. So you gather together, think of what you're going to do, you plan, split everything into tasks, and then you assign them to each other. Let's say you have someone focusing on the back end, or you can have someone focusing on the front end, someone dealing with the database, and so on. A hackathon usually lasts between, 24 or 48 hours, usually 24 hours. So you start on coding on your part, let's say on the back end, you develop it, write everything, you assume that you wrote the correct connectors to the database and everything. You assume that you have all the business logic there. And then on the front end, you work on the design, everything looks beautiful, and you just hope everything will work together in the end. Let's say you're now 20 hours into the hackathon, like the code looks good, everything's perfect, and then you decide to have everything put together because you're working on a product, not on a script in the end. So then you gather your team, try to connect everything together, and you realize that, oops, things are not working. What to do now? There isn't much to do, to be honest, because you only have 4 hours left of the hackathon. You need to make sure that you have something presentable. You need to work on your presentation, and you basically need to show a working prototype to everyone, right? So that's why, for example, we use at BlackRock Agile. That's why this is something that we recommend. We recommend having something built with small blocks and continuously iterating through it, always having a working prototype. Have a new feature, add it to it, test it. New feature, keep doing that, add it to it, test it.
Right, so you've heard the good and bad about Waterfall and Agile. So at BlackRock, we mainly focus on Agile because we felt that this is the process which has worked, and most of the teams in BlackRock use Agile. So how do we start this Agile process?
we start with gathering all requirements. Usually every team, especially at BlackRock, has a product owner. The product owner would then have a meeting with the executives and the stakeholders to decide and work around the products that they would like to have, all the features that they would like to have in their products. And then afterwards, the product owner will gather all the developers in his team and have a meeting on the requirements that have been gathered. So they'll go through them and analyze them and try to put them down into simple sentences. These simple sentences are called user stories. A user story can be something like, as a client of BlackRock, I'd like to be notified to receive an email when there's a change in my portfolio. And then for this, you have the sentence. And in order to make that true, to make that a true statement, you have to divide the work required for this into smaller components called tickets. We use Jira for this. So every Jira, every ticket will be a unit of work. And this should be estimated to the amount of time it will take for a sprint, which is basically a period in which we do our work, in which we iterate using the agile process that we previously described. Each sprint will have, let's say, an estimated amount of work required. So each of these tickets will need to be as atomic as possible. Let's say if we have a work that requires more than 2 days, we need to break it down. We don't know how, we need to find a way. Nothing should last more than 2 days. So we have this list of tickets that we created from the user stories. This will then make up a backlog. Backlog will then be your sprint, the first sprint that you start. So you kick off the sprint.
Yep. Once you kick off the sprint, you need to review it. And this is where we review with our daily team meeting, or as we like to call it, stand-ups. So in our stand-up, every single person has 30 seconds, no more than 30 seconds. You can have an alarm if you want. We've come up with some crazy strategies to make sure that we last just 30 seconds. And in those 30 seconds, we talk about 3 things. Things done. What did you do yesterday? So things that you did yesterday, things that you're going to do today, and any showstoppers, any issues that you've come across that you'd like help on. You go through this, 30 seconds. If it's more than 30 seconds, it becomes a team meeting. So we don't want it to be a meeting, a big meeting. We just wanted to share what we've done and we're going to do.
Yeah. As a sprint is like an iteration of your product, this will finish at some point. So at BlackRock, we usually have sprints of 2 or 3 weeks. So towards the end of the sprint, we'll have another meeting, another session with the team called sprint grooming. In here, we focus on the current status of the sprint. We look at the tickets and we make sure that everything is in the correct status, if we are on the right track to meet our requirements. And we also need to make sure if, like, the product owner had any other meetings with the executives or the stakeholders, because requirements always change. This is a fact. So we might need also to create more tickets. We need to be that flexible to allow modifications all the time. And we also need to start preparing for our next sprint. So how do we do that? We go back at the backlog, would still have some tasks, and we'll then create more tasks if required to meet the new requirements, and basically create a new offline sprint.
Yep, so once the preparation is done, then once that preparation for the next sprint is done, you actually do the sprint planning. And in this sprint planning, we close the current sprint. Once we've closed the current sprint, we then move on to the next thing, which is the retrospective session. So in this retrospective session, we look back and we see what have we done well in this sprint, what have we done not so well in this sprint, and what are the action points that we would like to take to carry on for our next sprint. So we focus on these things. And during the session, at the beginning, right at the beginning, we look at what are the different things that we would like to take from our previous retrospective that we can take it on to this sprint for our next sprint forward. Have we done the previous retrospective action points properly? So those are the things that we want to focus on in the retrospective session. And once you've done with the retrospective session, you know what's going to happen? You stop the whole process again. End of the 2 week or 3 weeks, you stop the whole process again. So here we've talked about the processes involving around development. So rather than focusing on just the development, we focus around the development, the project management methodologies that we can use. But I'd like to dig in more into the development process itself. So we use version controlling. I hope everyone here uses version controlling, otherwise it's going to be crazy. And the most famous version controlling right now is Git. So we use Git at BlackRock. And using Git has helped us a lot of times in order to, if we've made an issue, we can always go back, and it helps us with tracking our code. So how do we do this?
So each product that you handle can have multiple projects because they can represent multiple components, like the back end, front end, and so on. Each of these projects is also called or has a repository. And the repository is the place where everything is stored. So every repository will then have a master branch, the master branch being the most stable branch you can have for your project. So for example, if there's another team or some friends that would like to use your application, or they want to develop a plugin for your application, this is the branch that they need to check out. Also, moving on, there's also a branch called develop branch. This is not as stable as the master branch, but it is the one which has the most of the updates. It's the one which has the most features, and this is the one that you should be doing and focusing your development on. Speaking of development, earlier we were talking about Jira tickets. How do you handle a Jira ticket? You pick it up from the Agile board and then you create a branch. Where do you create it from? From the develop branch, and this will be a feature branch. You do all the development on the feature branch, make sure everything's working, do your testing locally, and then you create a pull request to push your change back to the develop branch. All the team members in your team will then need to review the changes or leave any comments if there are any to leave, and if everything's fine, you can just merge it back. You do this now with all the Jiras that you have in the sprint, and after a while, if your team is ready for a release, if you think you're ready that you meet the requirements, you then create a release branch. You do all the testing, of course, and then this becomes the stable branch. If this is a stable branch, that means we can now merge it back to master branch. And of course, being the most up-to-date branch, this also becomes the develop branch.
Note that we've just got a feature branch. As developers, we're too proud to have bugs, so it's all features. So if you've got any questions, we've got a stall nearby. Do come and talk to us. There's 5 of us. We're more than happy to talk about Git, Agile workflow, just technology in general, or if you'd like to work in BlackRock, do come and talk to us. We've also got the hackathon team, global team, who participate in different hackathons as well as be as a partner in different hackathons. We go to different places, so it's always good fun. And with that, happy hacking. Thank you.
Thank you.
Awesome. One quick question to you guys. I assume that you've been to a bunch of different hackathons. What is the most important thing, in your opinion, at a hackathon?
Ooh, that's a tough question. So I think it's important to have a good team. But finding a good team is difficult. But it's always important to have a good team and have that collaboration and that cohesion going within the team itself. But because at the end of the day, even if your idea is average, it might be great if it's average, you can still make a really good hackathon out of it. And you want to enjoy the hackathon. You want to enjoy the hackathon experience as well. So it's a variety of different factors, but good team, good idea. Make sure you enjoy the experience. That's important.
Bogdan, do you have anything to add to that?
I agree to what Dilip said, but I would also want to add that at a hackathon, it's not important or not as important to have a working product in the end. It's good to, as he said, enjoy and also learn, because this is a great opportunity to learn new stuff. Allow some time for yourself to play with new technology, have fun, meet new people, and yeah, hack.
Awesome. Hey, let's give the guys one more round of applause.
Thank you.
Yes, and now we'll take a very quick break here for 10 minutes, so you can hit the bathrooms and go get some snacks. There's some soup available at the snack station, or at least there was just a minute ago. So if you're hungry, you could go and check that. And then after the break, we'll continue on with the program here on the stage. And then we'll get to hear about calls and text messages and how to implement those into your products. So we'll continue in 10 minutes. 10 minutes. Thank you. All right, we'll continue with the program here. Apparently, people are in the food line getting dinner, but hopefully we'll have people in the streams watching this, and that way people get all the info and all get to hear all the awesome talks continuing here on the stage. We'll continue with rather technical things, which is kind of the name of the game here at Junction. Next up, we'll get to hear from actually a partner that I believe has been a partner for 3 years, maybe? Yes, there we go. So starting way back in the first Junction 2 years ago, 46 Elks from Sweden was at the event helping teams set up really cool text message and phone systems into their apps and services. And they're continuing with that work here today. I think we had also some kind of a side event. Did we do that in Sweden? Yeah, we did that earlier. And now I think this will be a very technical speech. You'll get to hear how to implement the cool things into your services. We all know that email is super crowded nowadays, and if you can actually send text messages to your users, or even you have phone call systems set up, that is an effective way to get information and access to the users kind of, or get their share of mind, and that way have your information available. The service that 46 Elks has makes it possible to add SMS and voice to applications or services super easy. The API has phone calls, SMS, and multimedia messages, I believe. I don't know who uses them, but I think some people do in some certain situations. That must be very useful. And like I said before, they have been partner multiple times already for Junction, and it's super cool to have them here again. Next up, I would like to invite Martin, who is a developer at the company, to the stage. Let's give Martin welcome.
Thank you very much. I will start from the beginning and finish in the end. So we start by the history. So my name is Martin Harari Turesson, and I was born in 1983. And I started to play around with telephones in around 2001 and did some stuff in between. And in 2015, I started in 46 Elks. Thank you. So this is the timeline of the telephone, more or less. So in 1876, the first telephone was invented. And in 2011, the 46 Elks API was created. So we can access the telephone network by the REST API. So the first telephone, this is the famous picture, has had some nice features. You can hear each other. Have some downsides. There was only 2 telephones, so if you wanted to call someone else, there was not much you can do. And you didn't know if someone else called, because there was no ringing functionality, so you had to listen all the time in the telephone. And one more thing was that people were kind of scared and said, "This is sorcery! We can't trust this. This technology will take over the world and we will not be able to survive here." But shortly after the first telephone was created, a very important part of the telephone was created. It was the crank. You know, old telephones you had to crank. And that is to inform the other end that I'm calling, please pick up. And they also had a bell in the middle here, so you can hear when it's ringing. So still today, modern telephones have the same sound often. But as soon as you have more than 2 telephones, you have problems, because you don't want to call everyone at the same time. So that when the switchboard was created, as we can see on this picture, and initially it was completely manual process. So you start by calling the person in the switchboard, and that person mechanically connected your phone call to the person you want to speak to. This takes a lot of workforce. And also, if you wanted to call outside your own city, it normally required several stations to forward your calls, and all of it was manual. So making a phone call from, let's say, Los Angeles to New York could take several hours to complete before you can actually start to speak. So this was the next step in the development. That was automation of the system. One of the first really huge automated system. And the invention of pulse dialing and this type of old telephone where you will actually turn the dial disc and it will make pulses to tell this old device where to mechanically move your connections to actually connect you to the other person. And this was super good. And it saved a lot of money because you don't have to have a lot of people doing the connection anymore. However, people were scared and said, this is sorcery! Because now the telephone understands self, it's artificial intelligence, it will take over the world. Super scary. And some years went by and electronics started to appear. And the pulses were replaced by tones. And those tones you might have heard sometimes in the telephone when you push a button when you're on the line. These tones were used to communicate between the operators as well as in the telephones themselves. It's faster and more reliable. It's called in-band signaling. And I actually had to return to this technology this morning because Elisa here in Finland doesn't support a more modern technology than this. This was released in 1963. And similar signals were used also inside the telephone network. And this was the time of the first hackers. Because the signals were in the system and they were on the same phone line as the sound, you could actually manipulate the telephone system by sending these same tones while you were on the line. You could make free phone calls in phone booths. Not very useful today, but you could at that time. Free long-distance calls, and you could also eavesdrop on other people when they were speaking. And so they were actually called phone freaks because the word hacker was not invented yet. And people said, oh, this is scary, this is sorcery, what should we do? And quite a few of these people were put to jail. Some years later, it was decided, we should not have this system where people in their own phone line can manipulate the phone system. So several versions of this signaling system was created. So today we have a system named signaling system number 7, and it's the 7th version of the signaling system. It uses signaling separate from the sound, so by talking or making sound on the phone, you cannot manipulate the system. It's a huge standard. This is some part of the different parts in the standard, and each of these documents are quite a few pages long. It's implemented in most countries, and it's what makes it possible to make international dialing automatic. And a lot of functionality we have today depend on the SS system working. And since it's in place everywhere, it's not easy to replace or change. So we are stuck with signaling system 7, even though we might not want it. One of the reasons signaling system 7, SS7 also, is that encryption, validation, and authentication of requests are very limited, which means that it's easy to hack. But it's hard to replace or change, so it continues to be easy to hack. So the telecom operators tend to protect their SS7 network at all costs from someone who they don't trust, because anyone who gets access can do a lot of very bad things. So, now recent days. There is something called the SIP protocol, Session Initiation Protocol, which is a protocol which is new, and I, in parallel now, will replace the signaling system 7. This protocol is only to handle calls, when to connect to who, and so on. And it also makes it possible from now on to, for example, make phone calls directly from a web browser to any telephone without any intermediate position. In practice there are, but the technology is the same all the way, which makes the future very nice. And it has encryption and authentication. And so far, the cell phone networks have had the same problems as the normal telephones. They have been on the old systems. But from 4G, SIP will replace the signaling used before, which means that we will have the same type of technology all the way in all systems. So you could easily transfer your call to Wi-Fi or to any other data transmission technology without worrying about future compatibility. Because you can just replace the data layer and you will be happy. And all of this is kind of there is many painful parts of my job when it comes to working with the telecom operators, because they are still using old signaling system with all kinds of crazy quirks. So what our product does is that we have decided, let's not give this pain out into the world, but let's keep it to ourselves. So we create an API which is based on normal REST requests. So you make normal HTTP post and HTTP GET and so on to make the phone system do what you want, to connect calls, to send SMS or MMS, for example. And here you can, on this link here, you can get information about us, of course, and we are also in the Game Jam corner, so if you want to see us, please come by. If you want any help with your telephony, perhaps your users want to be informed about something, and we can help you. And also, anyone who thinks our logotype is nice and tries out our API will, of course, get a nice 46LX t-shirt. In addition, for the team who uses our solution in their product has the possibility to win books, programming books, and a 46LX Forever account, where you get 46 SMS per month to send for the rest of your life. So hopefully a very long time. Thanks for listening.
Super. So we actually didn't go into the technical details on how your platform works.
Sure.
But does somebody in the audience actually want to hear more about that? How hard is it to implement, to get, those text messages going?
Yeah. So
how hard is it?
On a scale from 1 to 10, I would say 9.75. So there are many obstacles when it comes to the telecom network. So one of the main ones, I think, is that each operator and each country have their own set of standards. So I say, the signaling 7 is implemented everywhere differently. So this is what makes it hard. And every operator, like I said earlier, Elisa here in Finland, they use a different standard than the other operators to allow you to press the button on your phone. This is not documented anywhere. This is something you have to find out yourself. And also with the SMS, it's the same. Some operators like Telenor in Norway, if you send a short link from Bitly and include the Swedish word congratulations, grattis, they will not deliver your message because they consider it spam. They don't tell you, they don't document it, but they do it anyway.
Inspiring. Okay. It's your have you been personally 3 times at Junction?
Yes.
Or, yeah, you have.
Yes.
Why do you keep on coming back?
It's fun. And I listened to the speech about assembly, and I really like this concept that hackathons is really the basis to make people get to know each other, to challenge their beliefs, challenge their knowledge, and really push them to do something that they wouldn't do otherwise. And I'm actually a little bit scared, like in Sweden especially, the focus is, there should be more companies coming out of hackathons. And it's like, no, that's not the point. It should be fun. People should learn stuff. People should get to know each other. People should, this is why I'm here.
Very good. One last question. At least I've been thinking always, I haven't heard the background story on the name of the company before. What's the ELK? The 46 is the Swedish kind of the country code,
yes,
right?
That's correct.
But why ELKs?
Yeah, so I don't think there's a real answer. I told Yle the other day that it's because the 46 cows didn't sound as nice. But then otherwise it's because I think it makes a good logo type. And it's kind of Swedish or Nordic as an animal, so it also feels that way. But I think the main reason was that the domain name was free.
That's always a good sign, though. I mean, if you think about any of the big companies, Google, etc. Yeah, awesome. Hey, let's give Martin one more round of applause.
Thank you.
Good. Then we'll continue with the talks here. We have 3 more for you guys here today. And now we'll turn into the world of design. I mean, lately, design, I would say the past few years, design has become more and more important in the world of startups, especially. If your design isn't top-notch, you're doing a consumer product, that could kill a product. It's not okay to have something that looks okay, works perfectly, but looks just okay. Design has really kind of become an important part of developing new cool things. And also at hackathons, I think that if you have cool design, so that it just doesn't look like something very quickly brought together, but something that actually looks really cool and nice and clean, I think those types of projects do stand out in the different types of situations. So the next speaker will be talking about design, obviously. He previously worked on Migo, which was, in my opinion, perhaps and still is the coolest operating system there ever was. It was the one that Nokia was building before they jumped into the Windows Phone world. And since then, he's also been working at Microsoft in Fjord, and nowadays works at Sealy, and has also been a visiting lecturer at Aalto University. Without further ado, I would like to invite up to the stage Mitch from Sealy.
Thank you.
Thanks.
Hello, everyone. All right. Okay. So now we were talking about lots of technical, so I'd like to talk about more like a culture, how we can work together with a design spirit. So embracing design thinking, obviously orange is our color, Sealy. So if you find anyone in the foodie with orange, is probably us. Okay, first of all, Sealy means in Finnish, it's hedgehog. So that's good to know. If you Google hedgehog Sealy, you can find us. So we are not selling any product to any of you, but we are selling a solution to the companies. It's not a very easy business. We learn a lot of stuff over time. And the context we are in our business, and then how am I going to work with our customers, clients, companies. And we found many companies, even us, fail to provide their client what they really need. And that need is very important, because otherwise they pay us, we don't make anything good. So And that's why when it comes to starting a project, for instance, now you are enjoying these junctions, we try to make so that everything starts from finding the right problem to solve and what are the underlying human problems needs behind the challenges. That means I think it's better to even spend 1 week to try to find out which problem we are trying to solve for. Sometimes people want to go jump on to the solution, but it is very important to think about what is a real problem it is. Because in our business as a city, our company is having a difficult times. As you can see, as a kind of a user of digital age, we change our behavior completely in last 10 to 5 years. So to say, the same things is happening in businesses so that many companies cannot really predict what our company is trying to be in the 10 years or 5 years. So it's increasingly difficult. And at the same time, they make product, and then it's not about product making. They need to keep customer happy, so it becomes like a service-oriented. And in that case, it needs to have new methodologies, new thinking, and a new kind of creativity. And that's why we need to kind of come in with the design thinking. How many of you know design thinking or have heard about? Okay, yes. So it's not a new word, so I don't want to talk about as a new things. So there's a history already over the last 30 years. In the 80s, there's several books about design thinking, and David Kelly from IDEO has basically adopted this design thinking for business purposes in '91. By definition, by using design thinking, you can make decisions based on future consumer, relying on what they really want, instead of people are trying to looking at the data from the past. Can we do? What kind of risk we have? So it's really about going to the consumer market, going outside and researching and find evidences, and that's where I try to find futures for. And in that case, I also want to try to embrace how individual of us can embrace design thinking as an employee or hackers or designers, developers or business person and so on. So first of all, competitive edge, as I mentioned, it's really hard to predict. That means you don't have a silver bullet in the beginning. That means you fail and then try to find a improvement. So through the iterations, you get some kind of solutions in the end. In the beginning, you don't know where you're going, but through the failures, you can succeed. At the same time, we actually found several companies, even in Finland, has embraced design thinking for strategical decision making. And that's a very encouraging, because we thought about talking about design thinking from company, employee level, but actually companies already start embracing whole. So that's also changing whole culture of way of working. Instead of looking at the data, why don't we go out and look for evidence to how people want? And at the same time, this also means to us individually that we are not waiting for tasks by the company that, okay, now you do this A task. Okay, I've done a task within 1 week, so my performance is 100%. But that's a very old style. Instead, you employee or individual people, hackers, have to think about overview at the same time you are doing a stuff. Then you can find a meaningful work, though, so that what you are doing this for. Then, back to meaningful work, I also like to ask every one of you and every one of us that think about what we are doing, everyday life, and can we think about design thinking in everyday life? daily work, studies, while you're job hunting, and so on. But when you are tackling this design thinking approach, there is a balance, because it's not about your expertise, it's about thinking about whole pictures. To think about whole pictures, there's a good tips about 3 things. So first, obviously, you have to think about desirability, what people want in the future. Then, if you team up with hackers for these junctions, you are making something. So you also need to know what we can make. Sometimes you cannot make, but sometimes you can make really, really well. And the most important part is having a holistic view, so that where are you going? So how would you like to succeed by making this stuff you're making right now in Junction? So that's a viability. And we found good design thinker has at least those mindsets. First, obviously, you have to be a hunger for problem solving. That means we've also find some people are optimizing problem, so that you see problem, but after 1 or 2 weeks, you optimize yourself to the problem so that you don't even notice as a problem. That's a very problematic. Instead, when you happen to find a problem, why don't you start solving the problems in daily life? And also, this is also important for people like you, a hands-on person. Like, we also need to set ourselves a bit back to see the holistic understanding, so big picture, as we say. So curiosity to the big picture, so where is going to the future. Then if you compare the future and what you're doing as a staff right now, you see some gaps. Okay, we need to adjust. So in that case, we need to be open and then listen to other suggestions from different expertise. And also, this is also important so that, let's say, when it comes to changes, people starting worrying about any changes. So talking about risks instead of kind of success. So after all, overall, the team spirit has to have optimistic about future. Okay, we can make this instead of talking about edge case. If you fail this, we lose this much of money. So we can't do it. We shouldn't do it. It's not very good discussion to do that instead of optimism. So this is all about my talk. It was very condensed, so I hope you get something. So if you have something, please find us in orange, upstairs or downstairs. Thank you.
Super. Any questions from the audience? Could we break We've had only one question today, I think, from the audience, so. No? Okay. Well, then I'm gonna, oh, there we go. Awesome. A question. Can we get the catch box? Where's the catch box? There we go. Could we have somebody throw it all the way to the other side of the auditorium? This is a good team exercise. Oh. Perfect. Okay, awesome. Go ahead.
Oh, wow, it works. Hi, thanks for the great speech. I've actually been trying to implement design thinking into multiple areas of my life, and one of the biggest difficulties is actually waiting and doing the research before starting to solve the problem, creating the solution. How do you go to it that you actually gather enough research before you start creating the solution?
Yes. So you're asking about how do you set the problem to start?
Yes.
Yes. I think good attitude is question yourself. I have a really good colleague called Harry. He is also mentoring. He's very keen on business, and I'm keen on design. So designer usually wants to create ideas, or if you are developers, you want to go forward all the time. But Harry is a really great guide. Question me why all the time. Through this why, I found myself that, shit, sorry. But anyway, I found, okay, our path that we are going to is sometimes it's not really targeting the right problem. So asking why questions in the beginning especially is helping you to find the right problem. It's really hard in the teamwork because if you ask your team members why you are doing this, it's kind of offensive. But so this is also a culture of way of working. That's why I'm presented. It's kind of attitude towards that. And it's not all about one designer do this. It's about teamwork. Yes. But thank you for a great question.
Then maybe one more question from my side. In a hackathon setting, you don't have that much time to go and do kind of research on exactly what it is that the end user might want to get. Yeah. So in this kind of a setting, how could you kind of still implement that design thinking so that you still have time to actually develop something during the weekend?
I think in that case, my personal technique is, we are all humans. We have a common sense. So one slide might kind of break through the actual problem we are talking about. And in that case, think about common sense. Why people having a phones? And is that a problem? And you just highlight, let's say, I can't think about one example yet, but think about common sense in terms of problem. People hasn't found as a problem, but if you just nail down one slide, one problem to start with in your pitch or whatever, that's make many doors open and easy to push your solution to. I hope you get, yeah.
Cool. Then maybe just one last question about kind of your past. So did you study design when you were getting started, or did you kind of just gravitate towards design, or how did you end up where you are now?
I ended up with I have a design education, but I started from architecture. Okay. And this is how probably some of you are architecture background, and architecture is about overview, society, and sometimes it's relevant. I never designed any building, or I never built a single house. However, that education of studying about holistic view is always helping. So if you have a chance to think about holistic view as a study, you should embrace it. It's a good approach to think about small things, at the same time think about big things. It's really good for your career, I'm sure.
Awesome. That's a great concrete tip for the audience. Thank you so much, Mitch.
Thank you.
And now we're down to 2 more talks for today. Next up, we'll get to hear about something that, like I said before, is super tough. So if you are actually going to start a hardware company, that is hard. Everybody says always that it's freaking hard, it takes time, it's super expensive. So how do you do that? And next up, you'll get to hear from Velimir from Eve Tech on how they got their computer off the ground.
Thanks a lot for the nice intro.
A warm welcome.
Hello, everyone. Good evening. So my name is Veli, and as Paik said, I'm from a small company called Eve Tech. So now some of you may have heard of us, some may not. Obviously, we make hardware devices. As Paik said, the form factor is similar to that of a Surface Pro, so it's a 2-in-1 laptop tablet device. But before I tell you a bit about the device, I'm going to tell you a bit about the company, because that's really the core of who we are, and that's really the core of the device. So about a year and a half ago, we were just a few regular dudes who wanted to buy a cool laptop online. And we looked and searched, and we really couldn't find anything that we like in every aspect. So it was either lacking in terms of the price, it was either lacking in functionality, in versatility, or any number of things, the portability, the battery, and such. So we figured, as any other regular dude would say, why not make it ourselves? And we figured that the best way to do that is to start a forum, start asking people for advice, start asking people for input, and make the best device out there. So we started a community of called Eve Community. Today, the community number is about 6,000 people. Back in the day, we started with just about 10 of us. And we've grown and grown, and when we were about 1,000 people in the community, that's really when we started doing the work on the device itself. We were polling each other on every little aspect of the device. We were looking at what's present on the market and what we think we can do better for less. So either for less price, for less hassle, and stuff like that. So what this approach offered us is, unlike the big players out there, we can focus on making a device that's better, that serves the purpose of what we're creating it for, and still have the price point cheaper. So we set out to create this. It's called the Eve V. Now, as you see, the device is a similar form factor to that of Surface Pro. It's a 2-in-1 laptop tablet, but yeah, it has a lot that stands out from the market. So we wanted primarily to create a device that's going to be portable, that's going to be versatile, that's going to be your companion, so to speak. So we didn't want to focus too much on building a big brand that's going to be all flashy and everything. We wanted to create a device that can last you a long time, that can have a beautiful screen for you, but also be competitive with everything that's out there. So this is a little bit about the specifications. So it's a 12.3-inch screen with the best screen on the market, actually, currently, the 2880 x 1920. The brightness of the screen really is among the best, and how the screen itself functions with the device, it has very good battery life, actually. Compared to that of the nearest competitor, our battery life is 7 hours compared to about 5.5. We're also, our device is also king of ports, so to speak, as some reviewers may have called us. So we have 2 USB Type A ports, 2 USB-C ports, one of which is a Thunderbolt 3. So that's where the connectivity really comes in. What we talked about is, in a device that's a 2-in-1, it's a small form factor device. You can't really fit in a graphics card for all the graphic designers out there. But you can do that via the Thunderbolt 3 port. You can use a Thunderbolt 3 to connect to an external graphic card, and voila, you have a device that really has everything running for it. And finally, this is a bit about us, bit information about the company. Some of you may have been able to see it out on the hackathon floor out there, the device. We have a couple of devices out there. If you'd like to see the device, you can ask around, you can check it out, you can talk to me, and check our website out at eve-tech.com. And yeah, thank you very much.
Okay, so this would be the perfect opportunity for the audience to ask a question on how in the world were they able to actually get a hardware product built. And you're shipping the product right now?
Yes, we just started shipping the product, and we're actually opening our sales in a bit over a week on 4th of December. So, we're almost there. We're almost there.
Yes. And so the question was that, how were you able to do it? What is it? Is it kind of the culture of the company, or what's kind of the thing that made it actually possible to get the product out there to the market?
Yeah, so it was an uphill battle, as you may imagine, because when you come out, from a small country like Finland and a small team, back when we started the project, there were about 4 of us in the company. Now now we're massive. There's 8 of us. So it was an uphill battle because nobody kind of takes you seriously when you come out and say, yeah, we want to be better than Microsoft. We want to build a device that's better quality, that has more going for it at a lower price. Kind of people dismiss you for it, but we really didn't take no for an answer. We kind of had a goal of our own, and it was a grind. So one partner, another partner, please let us show you. But really what carried us through it is the community. So like I said, we started off with 1,000 people. We designed this device together. The community kept growing. The community is on 6,000 people today. Those people spoke for us when it was needed, and here we are.
And that's actually a good kind of way back to the previous talk. We were talking about kind of the need of the people. And so I think one of the kind of the main points here why it has been so successful is the fact that people actually, get exactly what they need and exactly what they want, because they've been part of kind of the process of developing.
That's really what we focused on. So creating a piece of hardware just to create something and to sell it isn't really feasible for a small company to do today. So you need to create something that's really necessary and that's bigger than just you. So obviously, this is bigger than just us. Those people in the community aren't the only people who need this device. And actually, if you take a look at our website, we're not selling yet, but we do offer people an opportunity to get in line, so to speak, so they can subscribe and get in line to buy a device once we start our next sales. We have a bit over 70,000 people, I think, at the moment, waiting in line to buy a device. Now, for a small company from Finland who still hasn't started selling, actually, that's quite big. And it kind of speaks to the situation of where the market is now and of how big companies could be doing a lot more to please the customers rather than just, pushing everything out and saying, this is what you need, rather than asking them, is this what you need? So
exactly. I mean, I think that's kind of an eye-opener on the whole idea of how should build devices and products. Awesome. Let's give Velimir one more round of applause for the awesome talk.
Thank you very much.
And now we are coming to the very end of the talks here on the stage. Next up, we'll get to hear from Jesus Fernandez about Qt. And funny fact, I'm a business student. I'm not supposed to be doing any coding, but I've actually used Qt in one of the projects that I've been doing. It was tough, but I actually got it to work. We're doing a Python, like a very simple kind of a paint program using Python, and then we had the front end built on top of Qt. It was super tough, but I actually got it to work in the end. So I've personally used, I think it's one of their offerings. And it's pretty cool, and if a business student can learn to use their product and then their service, I think anybody can learn to use that. And then after the last speech, we'll have a small break here, and then there'll be some more cool stuff happening here. We'll have, I think, some coding in the dark on the program a little bit later, and then some karaoke in the evening. So keep that in mind if you do get tired of coding at some point. There's also, I think, some food might still be available, so you might want to go and check them out. And if not, then we also have this different snack areas, so there you'll hopefully be able to find food. But now I think, do we have the presentation running? Almost? Yes? Maybe? There we go. Super good. There's some live coding going on. That's always good. But hey, let's give Jesus a warm welcome to the stage.
Hello, and thank you for coming to this small presentation about Qt. It's a brief introduction of what you can do with the Qt. I'm Jesus Fernandez. I come from the Qt company, one of the contributors to this open source project that is called Qt. Our name is the Qt company, but we are not the only contributor to this project. We have people from other companies that are collaborating with us, and many developers that they don't belong to any company. The meaning of this is that if you want to contribute to us, a lot of people will get your code, use it, have fun with it. This is a graph of the contributions. You can see the major contributions in this graph. What can I do with Qt? This is the important thing. You can create user interfaces. We have several models that allow you to create these interfaces. For example, Qt widgets that create all the old-fashioned widget-style applications. We have a new thing that we were creating for the last 5 years. It's called Qt Quick. It also has a new language. I will talk about this later. We are creating right now a new thing that is called Qt 3D. And there is also something called Qt 3D Studio that allows you to create user interfaces in 3D. Also, you can create console applications using a module called Qt Core. Server applications, you can create a HTTP server, for example, a WebSocket server, whatever you want. And of course, it's also used in games, used for representing data on screens. We have support for OpenGL, this new Qt 3D I talked about before. You can control gamepads with our model Qt Gamepad. Also, you can create desktop environments. One example is KD, which is one of the most used desktop environments on Linux or Unixes. And also, we provide the necessary stuff to be able to run your applications not only on Windows, on Linux, also in embedded devices, macOS also, and phones like iPhone, Android, and Windows Phone. This is something that is not popular lately. Here we have a short list about people who are using Qt. There are some big names in game industry, embedded devices, medical industry, for example, in TVs. Right now we are focusing a bit in automotive. So some of the new cars that you see that they have a fancy screen or videos or a web browser, some of them they use Qt for creating these interfaces. Also in the medical industry, we are there. And now let's see how we can create a small application with Qt widgets. This is the old-fashioned style of working with Qt. This Qt was created as a C++ in the origin, so this is what we have. We need to include this library that is called Qt widgets, and for that we instantiate a Qt application which gives us the interaction with the operating system, so we can create asynchronous applications, so we are not going to block the user. If he creates a button, for example, and we saw the button on a screen, we are not going to block. And if the user pushes the button, we can do some kind of action. In this case, we tell the Qt application to quit from our sample. It's something really simple. The so simple is simply to show the button we want on the screen, and this is where all the application runs. This is a really short example. It's not it's not a full application, but it's something that shows that it's really easy to create Qt applications using C++. In the second slide, I talked about a new Qt Quick framework. What's Qt Quick? It's a combination of a new language, well, new, we cannot say new because it has been there for some years, but it's a declarative language that was created in Qt during Nokia times. It also uses JavaScript, so you can create the interactions between the user and the application using JavaScript directly. And of course, you can connect with C++ directly. So you can have a way to create an application that integrates into the native interface using this JavaScript code. a brief description of what is this. This is just an import that allows us to specify the version we want to use for Qt Quick. We instantiate a simple rectangle. We give it a size. The important thing about this is that this language supports a concept called binding. So in this case, it's not being used because we assign the sizes in a hardcode way. So we say that it's 640 and the height is 480. But we could bind these values to something else. We will see it in few lines. We assign a color black to the rectangle. So our background of the application is going to be a black rectangle. Inside of this, we instantiate a new rectangle that is going to be a child of the previous rectangle because there is some kind of parent hierarchy. And here we see one of these bindings that allow us to connect in some way values of from an object to another values from another object. In this case, it's quite weird because we are saying that the center of our rectangle is going to be assigned to the center of the previous parent. But here, well, let's continue with this one before. Here we can see a text object that is instantiated inside of the second rectangle. Also, it's as the center of the rectangle is assigned to the previous center of the other rectangle. We give a text, which is hello world, the typical example. It's quite trivial. But the thing is here, in the rectangle, we have a width with text painted width plus 20. This means that the size of the text we write, the text name is defined by this ID. So imagine if we change the text to hello world, hello Junction, the width of the previous rectangle is going to be different because it's assigned automatically. So we don't really need to write the code. Okay, on text change, let's resize the rectangle. It's assigned automatically. The same for the height. This is trivial. We assign a color white. Something interesting here, we also have a mouse area object that I think the name is not confusing. It's just to interact with the mouse. So here we assign the constraints in size, and we say that it should fill the parent. In this case, this rectangle. We have some special bindings that are called signals that we can assign when the user clicks in this mouse area that is filling this rectangle, we need to do something. In this case, we can put some JavaScript code here. In this case, we are calling a special function of Qt that is quit, and it will finish the application. It's something really simple, but it can show more or less how a Qt application can be right. So we have C++ API and also this Qt Quick API. And they can be combined if you have something really complex or you need to use a C++ API. Of course, you can use this API from Qt Quick with some helpers, and you need to write a bit more of code, but it works. And that's all. It's a really brief presentation. Thank you for your time.
Super. I'm going to ask the default question. What would be the coolest thing that somebody could build, in your opinion, during this weekend?
Let's see. I don't have any idea.
Okay.
Maybe something, I don't know, somebody comes and creates a cute 3D application that allows us to go to a virtual world, something like this.
Yeah.
Combining cute 3D and virtual reality, why not?
Sounds pretty ambitious. Cool.
Yeah, why not?
Have you done, so you're quite technical though, right?
Mm-hmm.
Have you had any awesome personal projects that you've been super proud of?
Not any. I created several games in my spare time, but nothing really interesting. Nothing. I mean, I code just for fun, and later I remove the code from my hard disk.
Okay. Okay. Interesting. And last question: your laptop, it's set up in a rather interesting way. Do you want to demo that really quickly?
What do you mean?
So you're running some kind of a Linux on top of there, and then.
Well, first of all the presentation is using Qt Quick. So if we can see here in the screen that this is Qt Quick code. We have something that is called QML presentation system. So it allows us to create a presentation with customization. We can click and show, okay, we highlight this line,